Department of Science, Technology and Innovation, Dr. Madira provides a strategic leadership in advancing research, excellence, strengthening scientific innovation, and championing women's participation in science through national initiatives. She holds a PhD in public health and recognized for her academic contributions as she continues to drive transformation and impact through communities. Ladies and gentlemen, allow me to welcome Dr. Maphuti Madira as we will gain insight and inspiration from her voice that is committed to building the future of science and innovation. You're welcome, Doctor.
Seems like I'm taller than her. Program directors, I need your attention. Program directors, executive dean online, deputy executive dean, head of the college, distinguished academics, colleagues from the NRF, from CSIR, from DSTI, industry partners, students, ladies and gentlemen. Industry executive dean, head of the college, distinguished academics, colleagues from the NRF, from CSIR, from DSTI, industry partners, students, ladies and gentlemen. It is my honor to give this keynote address at this important Research and Innovation Day hosted by the college under the sub-theme Transforming Lives through Innovation in Biotechnology, Marine Studies, Health, Energy and Digital Advancement. Allow me to thank Professor Mabelebele and the colleagues and the college for inviting me and for creating this platform that celebrates research excellence, innovation, collaboration, and the development of future scientific leaders. Today's gathering is extremely important because it ignites conversations about the future, conversations about how we prepare for the next generation of researchers and innovators, conversations about how we ensure that science responds to societal needs, conversations about how we create inclusive opportunities especially for women and young people, and finally, how institutions like Unisa can help shape and contribute to the national system of innovation. Research and innovation are essential instruments for economic growth, for climate resilience, food insecurity, industrialization, and global competitiveness. And this day reminds us that science must not remain locked inside laboratories, inside journals, or lecture halls. Science must engage communities, it must shape policy, it must solve problems, it must also inspire hope. And perhaps most importantly, science must create pathways for those who will inherit this responsibility of building South Africa's future. And that is why creating pathways for the next generation of researchers and innovators, more especially for women and young people, is both timely and urgent. The question is, why does science, technology, and innovation matter? South Africa faces multiple interconnected challenges. We face youth unemployment, inequality, climate change, food insecurity, energy challenges, public health pressures, and the rapid transformation of the global digital economy. And none of these challenges can be solved without science, technology, and innovation. We cannot grow our economy without innovation, which can create jobs and industries. We cannot respond effectively to pandemics without health innovation and biotechnology. We cannot build climate resilience without environmental science and renewable energy solutions. And we cannot strengthen agriculture without research in food systems, soil science, water management, biotechnology. This is why the Department of Science, Technology and Innovation continues to place science, technology and innovation at the center of government, industry, education and society. Science and innovation are no longer peripheral sectors. They are now central drivers of national development. Countries that invest in research and innovation are countries that industrialize faster, they attract investment, they actually create knowledge economics, they strengthen global competitiveness, and ultimately improve the quality of life. So the global economy is increasingly knowledge-driven. Nations that fail to invest in scientific capacity risk being left behind. South Africa, therefore, has the responsibility to strengthen its national system of innovation and to ensure that our young people are equipped to participate meaningfully in the future economy. Our work at the DSTI is guided by two critical policy frameworks, the 2019 White Paper in Science, Technology and Innovation, and the STI Decadal Plan 2022-2032. And these policy frameworks recognize that people are the creative core of the economy. The White Paper emphasizes inclusivity, transformation, skills development, innovation capacity, and equitable participation in science. And importantly, it acknowledges the historical inequalities that continue to shape participation in research and innovation. And for many years, access to scientific opportunities was uneven. Women, Black researchers, rural communities, and disadvantaged institutions often lacked access to resources and opportunities. The White Paper, therefore, calls for deliberate interventions to transform the system. And the Decadal Plan expands this vision by identifying strategic focus areas, which include modernization of industry, digital transformation, circular economies, climate adaptation, energy security, health innovation, advanced manufacturing, and education. The Decadal Plan also emphasized partnerships. Government alone cannot transform the national system of innovation. Universities, science councils, industry, communities, and international collaboration must work together. And this is why institutions like Unisa are so important. Unisa occupies a unique position as South Africa's largest distance learning institution, expanding access to higher education, research, and innovation opportunities across the country. And the College of Agriculture and Environmental Sciences is particularly important because its work directly addresses national priorities such as food insecurity, environmental management, marine studies, health innovation, water security, and also agricultural innovation. And importantly, the college has positioned itself as a critical contributor to research excellence and innovation by developing emerging researchers and producing solutions such as the acid mine drainage innovation that responds to real societal challenges. The future of our country depends heavily on how we respond to these challenges. And therefore, creating pathways for the next generation requires more than inspirational speeches like I'm doing now. It requires systems, it requires investment, it requires mentorship, it requires opportunities, and more than anything, it requires intentional support. At the DSTI, human capital development remains one of our central priorities. We recognize that South Africa's future researchers and innovators need access to quality education, they need postgraduate training and funding, they need research infrastructure, mentorship, they need international exposure and recognition. This is why the National Research Foundation, colleagues from National Research Foundation, this is why you play a critical role as our implementing agency in supporting postgraduate bursaries, research grants for emerging researchers and established researchers, infrastructure support, research chairs, and centers of excellence. These programs create pathways from undergraduate studies into advanced research careers. And I believe that my colleagues, Melissa and Frank, are going to talk more about those opportunities from NRF. And government also continues to invest in other postgraduate support initiatives aimed at strengthening research capabilities in priorities areas. One such initiative launched in 2016 and it's managed by CSIR, ARC, and SANZA, support honors, masters, and doctoral students in areas such as agriculture, ICT, advanced manufacturing, bioeconomy, indigenous knowledge systems, photonics, and space science. And the DSTI HSRC internship program is another important national skills development initiative that continues to bridge the gap between academic training and professional readiness. Since 2005, the program has placed more than 6,000 interns across more than 100 host institutions, with 88% of those graduates being Black and 64 being women. These programs contribute significantly to building a skilled, transformed, and diverse research workforce of South Africa. We must also recognize that mentorship matters. Many successful scientists still often speak about the importance of mentorship, who guided them, who encouraged them, who opened doors for them. Young researchers need to supervisors who invest in them, not those that give them stress, institutions that believe in them, and ecosystems that allow them to experiment, to innovate, and to grow. The department is supporting an important initiative through Universities South Africa, known as the Advancing in Early Career Researchers and Scholars program. This initiative has a platform specifically focusing on addressing mentorship gaps within the higher education, particularly for emerging researchers. And there are many other useful resources for younger researchers under this initiative. So I will encourage our young researchers to go and explore those opportunities. We also have the South African Young Academy of Science, which provides vital platforms for young scientists to engage in policy, to outreach and international collaboration. Through CAES, emerging researchers gain opportunities to participate in science diplomacy and advisory roles, access mentorship, and networking programs, and represent South Africa in global young academies and forums. Our researchers should also take advantage of the opportunities provided by the South African Council for Natural Scientific Professions, commonly known as SACNAPS, which serves as our regulatory body for natural scientists in South Africa. SACNAPS offers professional registration opportunities for scientists in the fields such as chemistry, geology, biology, agriculture, and environmental science, just to name a few, while also supporting career development and professional recognition. Importantly, professional accreditation strengthens professional development within the scientific community. We must also build environments where curiosity is encouraged. The next generation of innovators must feel empowered to ask bold questions. Innovation often begins with one question: what if? What if we could improve crop resilience? What if we could improve renewable energy technologies? What if we could develop local solutions to local problems? We have to create pathways that are not only academic, but they must all include entrepreneurship and commercialization, because research that remains on the shelves cannot transform society. We therefore need stronger partnerships between universities, science councils, industries, government, and international networks, because no institution can succeed alone. Research and innovation thrive through collaborations. Universities produce knowledge, industry often scales up solutions, and government creates enabling environments. Through the Technology Innovation Agency, the department supports seed funding for early stage validation, prototype development, technology transfer, and commercialization support. Young researchers and innovators must understand that They must understand that research can lead not only to publication, but also to startups, to patents, to social enterprises, industrial solutions, and also economic opportunities, which is what we need in South Africa. When these sectors work together effectively, innovation becomes more impactful. We must strengthen knowledge transfer and ensure that research outcomes benefit communities and contribute to socio-economic development. There are also growing international opportunities available to researchers. DSTI support participation in the BRICS Young Scientist Forum, the Lindau Nobel Laureate meetings, and I believe that our 6 young scientists will be leaving to Germany in the next week or so. Horizon Europe programs, which have doctoral and postdoctoral funding opportunities, international mobility programs, and also we have bilateral and multilateral research collaborations. And these programs expose researchers to international networks. It exposes them to collaborative research opportunities, advanced infrastructure, global innovation ecosystems, and also scientific exchange platforms. Such exposure is critical in preparing South African researchers to participate competitively within the global knowledge economy. No conversation about pathways can be complete without discussing inclusivity, because transformation is not optional, it's necessary. South Africa cannot afford to exclude half of its talent. The 2024 Facing the Facts report reminds us that while women now make up to more than half of said graduates, they remain underrepresented in leadership positions, in research publications, executive roles, and also in decision-making structures. And furthermore, women in science continue to face barriers, including unequal opportunities, limited mentorship, funding disparities, work-life balance pressures, and under-recognition. This tells us something important, that opening doors is not enough. We also must ensure that our women are supported, recognized, promoted, and represented in leadership. DSTI continues to support interventions aimed at addressing these gaps. This includes, and not limited to, the South African Women in Science Awards, formerly known as SAWISA, where we recognize research excellence. The call is currently open, closing on the 31st of May, and I hope that you will be applying and so that we can recognize you. We have the International Center for Genetic Engineering and Biotechnology. It's a Women in Biotechnology program. And the Organization for Women in Science for Developing World, South African National Chapter, just to name a few. And these are the opportunities that you can have a look at, because we believe that recognition matters and it multiplies impact. When young girls see women scientists leading laboratories, winning awards, publishing research, and influencing policy, they begin to believe that they too belong in those spaces, because representation creates possibilities. We must therefore continue building visible pathways for women and girls into STEM education, into postgraduate research, into leadership and entrepreneurs' opportunities and recognition. Across the national system of innovation, we celebrate excellence through a range of prestigious awards that inspire and motivate us. We have the National Science and Technology Forum Awards, often called the Oscars, the Science Oscars of South Africa. It recognizes outstanding contribution across science, engineering, technology, and innovation. The Technology Top 100 Awards, which celebrate technology-driven enterprises. The National Research Foundation Excellence Awards, which acknowledges researchers funded by the NRF, and I believe Professor Mabelivile is one of those researchers that was recognized by NRF. And we have TIA Grassroots Innovation Awards, which support early stage innovators and community-driven solutions. And lastly, the L'Oreal UNESCO for Women in Science South Africa program, which empowers outstanding women researchers, advancing scientific excellence and inspiring the next generation of women in STEM. Together, these awards build a culture of recognition that multiplies impact, positioning our researchers as role models and ensuring that their work resonates far beyond academia. Colleagues, I would like to acknowledge the excellent work of the women researchers at Unisa, who continue to inspire the next generation of researchers. The likes of Professor Mabelebele as our host, as I already mentioned, Professor Tebogo Mashifane, who's an NRF-rated researcher and a multi-award winning researcher, Professor Patience Mtunzi Gufa, as well as Professor Usisipo Ufeleni, just to name a few, who have benefited from these opportunities that I just spoke about. Their achievements demonstrate that excellence and transformation can go hand in hand. South Africa has made important progress. If you look at the 2025 STI indicator report, it highlights encouraging developments of improved demographic representation in universities, growth in PhD qualified academics, increased scientific public outputs, and also improved digital governance, as well as a growth in venture capital investment. These are positive signs. However, we must also be honest about the challenges that we are still facing. South Africa is still faces a declining R&D, research and development expenditure, reduced global competitiveness, insufficient patent output, and dependence on imported intellectual property. And also the shortage in critical STEM skills due to a limited proportion of graduates doing STEM-related fields. This means that we must continue investing in mathematics and science education. We must continue investing in postgraduate pipelines. We must continue in investing in innovation ecosystems as well as our research infrastructure. We must also ensure that innovation reaches rural communities and historically disadvantaged institutions. Inclusivity is not only about demographics, it is also about geography and access. Young people from all communities must feel that science belongs to them. This requires sustained investment and policy commitment, the billion allocation to STI. This investment is not simply about funding institutions, it's about investing in people. It's about building scientists, innovators, entrepreneurs, and leaders who will shape South Africa's future. Colleagues, as I am about to conclude, allow me to return to the theme of today's keynote address, that creating pathways for the next generation of researchers and innovators is not the responsibility of one institution. It is a collective responsibility. It requires visionary leadership, it requires supportive institutions, it requires collaborative partnerships and inclusive policies, and more than anything, sustainable investment in people. The department's commitment to creating inclusive and sustainable pathways for the next generation of researchers and innovators is clearly articulated in our DCSTI strategic plan for 2025-2030. To 2030. The strategy prioritizes bursary support to disadvantaged institutions, prioritize increasing the participation of women and Black researchers, and mainstreaming indigenous knowledge systems into the heart of our national innovation agenda. The future scientists sitting in this hall this morning may become the innovators who solve food insecurity. They may become researchers who develop climate solutions. They may become entrepreneurs who create new industries, the leaders who will shape South Africa's scientific future. Our responsibility is to ensure that those pathways are accessible, those pathways are inclusive, and are empowering. We must build a South Africa where science serves society, where innovation drives development, where women and youth are fully included, and research contributes meaningfully to national progress. This Research and Innovation Day is therefore a reminder that the future is being shaped now, that the pathways we create today will determine the South Africa we inherit tomorrow. Let us continue working together to place science, technology, and innovation at the center of education, government, industry, and society. Let us continue investing in people, and let us continue creating pathways for the next generation of researchers and innovators, especially for women and young people. Program Director, thank you for your time.
Thank you, Dr. Madikha, for kick-starting us powerfully with our presentations today. I would like to call Prof. Semenyo to please say her vote of thanks to Dr. Madikha. Dr. Madikha, may I call you back? May I call you back? Thank you so much, Prof. Thank you so much, Dr. Madikha. Going forward, I'd like to introduce our next speaker. It is Dr. Patebile Ramalapa, sorry guys. Whoopsie daisies. Who leads the Biotherapeutics Formulation and Delivery Platform at the Council of Scientific and Industrial Research, which we know as the CSIR, where her team develops drug delivery systems for diabetes, breast cancer, and antimicrobial resistance engineered for the African climate conditions. Dr. Ramalapa has 2 PhDs from 2 prestigious universities abroad, with a research-focused area of material science, innovation, and modeling at the Northwest University, where she contributes to postgraduate training, research supervision, and capacity development within the biomaterials and health technologies. Dr. Ramalapa leads collaborative programs involving academia, industry, small, medium enterprises, and international partners to accelerate technology transfers and translation to strengthen regional biomanufacturing capacity. Her work is driven by a commitment to developing sustainable, locally manufactured health solutions that improve equitable access to medicine and advanced therapies across Africa. Right, without further ado, sir, thank you.
It's fine.
Good morning, ladies and gentlemen. I stand on all protocols observed by the previous speaker, Dr. Maputi Madikha. I'd just like to send my gratitude to the program directors, to the executive dean and the deputy executive dean, and to Professor Mabele and colleagues for inviting me for the Research and Innovation Week that's held by Unisa this entire week. And I feel privileged to be standing in front of you to tell you all about the little things that we do in the research platform that I lead at the CSIR that focuses on biotherapeutics, formulation, and delivery. So today I'm going to be talking about the formulations that we do where we are enabling clinical translation and commercialization for local manufacturing in South Africa and for the region as a whole. Yeah, that's fine. Okay, hold it. Yeah, that's fine. How do I move into the next one? Okay. So before I get into the work the research that we do, I'd just like to tell you about the division that I come from the CSIR. So as I mentioned, we're a research platform that focuses on biotherapeutics for biotherapeutics formulation and delivery. And we fall under the National Innovation Center for Nanotechnology that is sponsored by the DSTI under the division Future Production Chemicals. And the Future Production Chemicals Division is a division that develops and localizes sustainable state-of-the-art and innovative biological and chemical conversion technologies and products to support a vibrant, sustainable, and circular African chemicals, pharmaceuticals, energy, and industries in South Africa. And the cluster also has the responsibility and mandate to nurture the health portfolio to especially support the country in ensuring pandemic preparedness. And I won't talk to you all about the other things that are focused on energy and everything else, but I'll focus on the pharmaceutical processes and health innovation that we do where I am based, where we support the local production of drugs through the provision of fully automated integrated hybrid processing technologies, where we enable clinical translation and commercialization, and doing also medical countermeasures in innovation in support of South Africa and the continental medical sovereignty and pandemic preparedness, also developing synthetic biological capabilities for industry. We are currently implementing the synthetic biology roadmap for the DSTI as well. And as I mentioned, I work with bioactive compounds. So in context, bioactives have been emerging as the gold standard for therapeutic interventions for complex and difficult to treat conditions. And this is because they exert multi-targeted biological effects that cannot be exerted by small molecules. For example, in diseases such as metabolic diseases, rare genetic diseases, inflammatory diseases, and especially for oncology applications. However, bioactives are challenged in that there's a lot of formulation complexity with bioactives. It's very hard to manufacture them to scale because of the low stability and the degradation that they go through. There's also regulatory challenges. So if any of you know about our South African Health Product Regulation Authority, you will know that they do not do first-time applications for biologics in South Africa. So if you had a biologic that you had discovered a drug that was made of a bioactive, you'd first have to take it outside of South Africa to get any other regulatory body, such as from the EU or from the FDA, to be approved before you bring it back to South Africa to approve. So that is some of the regulatory challenges that we face as a country. There's storage and distribution constraints when it comes to biologics. So biologics are quite unstable, as I said, to degradation and environmental conditions. Therefore, they need what we call cold chain storage and distribution, which means that as a country like South Africa or in a region like Africa, where we do not have such access to such kind of resources, we suffer. If you remember when we had the vaccines, we brought them out of the country in Germany, we brought them here, they landed at OR Tambo. By the time they got to different provinces, some of them could not be used. We were lucky because we were in Johannesburg and Pretoria. We have the logistics to bring them here and still use them. Some provinces do not have the kind of logistics to take a biologic all the way from OR Tambo through storage, distribution, and transportation all the way to provinces like KwaZulu-Natal, Limpopo. And it's very hard to have biologics that we need to treat certain diseases like breast cancer, for example, to bring them to those certain provinces. And it's very hard to translate them to commercially viable products, specifically in South Africa, because outside of the fact that you have a drug and it's used, for example, like insulin, you have to think about user design in terms of, are all the people in South Africa who have diabetes eager to use insulin as an injection? And if patients are not going to use those drugs, it means that they then do not get cured from the disease. So it's about the logistics, it's about the end user design as well. Now we've got a shifting landscape that recently happened, especially after COVID-19, where we have advances in delivery systems, accelerated regulation that's also driven by COVID-19, where a lot of regulatory bodies found a way to accelerate the regulation of new biologics because of the processes and policies that were implemented during the COVID-19. If you remember, a lot of people said, why does medication take 10 years to regulate? And with the COVID-19 vaccine, they regulate it within a month and it's ready for human use. The debate is still there as whether it was ready to be out for human use. But even with that debate being there, we know that now regulatory bodies have the resources to be able to regulate faster when it comes to biologics, and hoping that South Africa will also be at a point where we can do first-time application regulation for biologics as well. So there's also modern formulation strategies that have been used with enhanced stability of biologics and scaling to manufacturing potential. So to give you an example of how when we formulate biologics, it gives us a better way of distributing these biologics to patients. I'll give you two examples that most of us know about. The mRNA vaccine that was used during COVID-19 and the glucagon-like peptide, GLP-1, which previously was used for diabetes 2 patients to regulate their blood glucose, but as research was done, it was found out that it also regulates appetite and is now being used as a weight loss drug. So with mRNA vaccines, these were discovered in around 1961. So I'll say in the 1960s. It first started in France or the USA, depending on who you talk to, because apparently the Nature publications came out right about the same time. So in the 1960s, researchers in France and researchers in USA discovered this thing called mRNA. They see that it's an intermediary for protein synthesis. And it's very good because you can synthesize proteins that can become therapeutics or vaccines for different types of diseases, because as we know, there are different types of diseases that we are discovering every now and again. So we need new therapeutics every now and again. So they discover mRNA, but they realize that when they deliver this mRNA to the cells, it doesn't go all the way towards protein synthesis because it starts as an intermediary for mRNA and it's supposed to end up as a protein that you can then use as a therapeutic or a vaccine. But it doesn't go all the way, meaning it's degraded by enzymes, it's unstable, you cannot even transport it because then it will be degraded by environmental conditions. So the challenges are that it has extreme instability and degradation, a very short half-life, low delivery efficiency because how do you deliver it to the cells if you cannot keep it stable? Unwanted immune responses. So RNases form in the body, when you introduce mRNA, it sees it as a foreign particle and immediately gets it out of the body, tries to destroy it. Manufacturing and scaling, if it's so unstable, how are you going to keep it in the lab that long and actually get it into a factory where you can scale it up? So those were the challenges that were faced with mRNA. So what are the solutions that formulating have provided? So with the mRNA, we were very lucky in that because there was a pandemic, the people who then formulated it, or the researchers who found the formulation, were then, I could say, coerced or forced to tell us what is this formulation that you were using to formulate this mRNA, because if we are going to regulate it faster, we need to know and we need to be able to tell people what formulation was used for this mRNA. So they used modified nucleotides so that they could protect it from detection and degradation by immune systems. And then they used encapsulation in lipid nanoparticles to protect it from RNAs following absorption through cell membranes. And if you remember, the first method that I talked about, the protection of mRNA using modified nucleosides, was the one methodology where they awarded the Nobel laureates to Professor Weissman and Professor, I can't forget this because she's a woman. I'll tell you later, I will remember. I feel bad for remembering the men and forgetting the women. So with GLP-1, the challenges is that it's a peptide therapy, so its success depends on injections, and thus it's harder to scale for broader patient use. Quick degradation in the body, it's a biologic, so it suffers from the same challenges that you would have with mRNA as well. There's poor membrane permeability. It interacts a lot with the acidic environment of the digestive tract. That's if you were to give it to someone orally, and thus it becomes a challenge to have it accessible in an oral formulation. So now we know that companies such as Novo Nordisk have now developed oral formulations using nanotechnology for GLP-1. And this means that overcoming these barriers has led to oral formulations of GLP-1. So if you're someone who is in this field and reads a lot about this GLP-1, you'll find out that it's been tested for different types of diseases, for inflammation, I know it hasn't been tested for oncology yet, but I know it's probably coming. But it's inflammation, it's neuro diseases, and a whole lot of other diseases that had been tested, that GLP-1 has been tested against. And being able to produce long-acting depot systems and increased shelf-life technologies makes it viable for wider therapeutic use. So coming back to our capabilities as the CSIR. So as the CSIR, as I mentioned, we are a national nanotechnology innovation center that's supported by the DSTI, and we've been supported probably since I was in high school in the early 2000s. So we've been supported by the DSTI for nanotechnology. Our platform for biotherapeutics formulation and delivery was established by myself in 2021. But prior to that, I was working in drug delivery in another platform that was for TB, for infectious diseases such as TB and malaria. It was just simply called the nanomedicine platform. So we have a lot of expertise in terms of nanomedicine and doing formulation and delivery for different types of molecules. We started with small molecules. We're now doing biotherapeutics because we see how biotherapeutics can be used in non-communicable diseases and how they have a wide therapeutic use when you use them, instead of small molecules where if you find a small molecule for TB, it probably stays as an antibiotic for TB for the rest of its time as a therapeutic. But with biomolecules, you can actually test it for different things and it can be pivoted for other uses as well. So we have capabilities in emulsion systems, which is the immiscibility of both hydrophobic and hydrophilic compounds to enhance solubility of those compounds, to enhance their bioavailability, for increased absorption across biological barriers, and for formulation of oral dosages, as I talked about, how when you have injectable biomolecules, it's not accessible to the whole entire patient population. So having oral dosages help with being able for patients to access the therapeutic. We also have skills in bioconjugated systems. So bioconjugated systems are like the ones that I described for the mRNA, where you conjugate via chemical linkage a polymer or a targeting moiety of a bioactive, and this is to try to hide it from your immune system from taking it out of the body as soon as it identifies it. So it gives it improved stability, enhanced circulation time in the body because it can then do the work that it needs to do because it's not gotten rid of by the body very early. It reduces segregation by enzymes or gastric juices in the body. And it's very good for combination therapies because you can imagine if you have the backbone of a polymer and you are able to chemically link that backbone to different therapeutics, you can, when people, especially for us in South Africa, where we have a lot of people that have things like TB, HIV, and pneumonia, and then acquire other diseases, you can then put the therapeutics on the polymer backbone for different kinds of diseases so that they take one formulation for whatever comorbidities they may have, instead of taking a lot of pills, which then produces each formulation or each drug, remember, produces its own side effects. And it's even worse for people who are immunocompromised. Built-in is lipidic systems, which for improved cellular uptake, improved shelf life, and preservation of the biological activities for different types of things. It was even used for COVID-19 as well. But you could only get it as a lipidic substance in oil form. But people needed to have it in dosage form, in oral soluble dosage form, so that they could use it as a drink, or also in low dosages, types to see if it could be used for kids. And in using it for kids, they were trying to go for neurodegenerative diseases. So we licensed this oral dosage form of CBD, where we were able to improve the absorption of the CBD so that it could come in an oral dosage form. System, you are able to facilitate intracellular delivery for hydrophilic compounds as well. So I think I've spoken about our strategic objectives when I was talking about the skills that we have. So I'll go through this one quickly. I think I'm taking up a lot of time. I was given 15 minutes and I think I'm at 20, but we'll also think about the technical glitches that we had when I first began. So we work in advanced formulation design where we are creating novel solutions. I've talked about the fact that we use nanotechnology. We use biopolymer modification, that's the conjugate linkages. We use emulsion systems as well. And this is to enhance stability, bioavailability, and overall efficacy of bioactives. Here, I'll just give examples of what we've worked on. We've been able to develop a thermostable insulin formulation that we've patented. This is to make sure that you can get insulin stable enough for it not to need cold chain logistics when you transport it and distribute it. Whenever I talk about a thermostable insulin formulation, people always ask me whether it's available in pills. Not yet. We haven't made pills. We just made it stable enough so that in future, any biopharmaceutical who licenses it will be able to transport it and distribute it without needing cold chain storage. We've done a macrophage targeted Gaucher's disease enzyme. People will ask why we would do a Gaucher's disease, because it's a disease that's an orphan disease. In South Africa, we don't even have a lot of patients that have this disease, but we were approached by an outside company that's outside of South Africa, and they went for macrophage, for Gaucher's disease because it's an orphan disease, and regulation, as I said, is faster. So in R&D, you always go for the low-hanging fruits. So if you can develop something for Gaucher's disease that can then be approved for regulation, you might actually use the same technology platform for other diseases. So you always go for the low-hanging fruits so that you can get something out commercially and then later use the same technology platform to get to other diseases that will then have a larger patient volume. I've talked about the advanced delivery systems. Here, I'll just give examples of what we worked on. So we started working on IKS because this is this is one of the areas that the DSTI is important for the DSTI. We know about the IKS Act. We know about all of the programs that the DSTI is accelerating in terms of IKS. So we use plant extracts and make formulations to try and get products out. So we know we've known now that when you have plant extracts, it might be very difficult to get it to a commercially viable product, specifically for therapeutics. It's good for cosmetics because you don't need regulation. It's good for nutraceuticals because you don't need regulation. We started with a low-hanging fruit. As I said, you always start with the low-hanging fruit. So we made a plant extract-based formulation for blood glucose regulation. So these are well-known plant extracts that are known to regulate blood glucose. We formulate them, enhancing their stability and bioavailability, so that if you buy it as a white powder in your vial, it remains white for the rest of the time that you're using it. Because sometimes if you buy plant extract-based formulations or nutraceuticals, you realize that after some time, your formulation actually changes color because it's not as stable as it meant to be. The bioavailability of plant extract is also quite low, so we enhance the bioavailability. Then we have a formulation of plant extract-based formulation for diabetic and chronic wound management. And then to take you on to the next one, this is then one of the formulations that we are using for secondary applications. So we took this formulation, turned it into different hydrogels, different films, so it can be used for chronic wound management and specifically for diabetic ulcers. In the development of secondary applications, we develop biomaterials. This is where there is no therapeutic involved. It's simply a biomaterial that we modify so that it can have therapeutic applications. And we've used one of these biomaterials for antiviral applications, demonstrating HIV inactivation in breast milk. I've talked about the antibacterial film that has antioxidant and anti-inflammatory activity from the plant extracts, and it's used for wound management. Here we use the biomaterial that has antimicrobial properties as well. We are getting there. So these are some of the commercialization efforts that we've had in the past, I could say 2 to 3 years, in terms of the formulations that we do. I talked to you about the thermostable insulin. So what we do, because we know of the fact that in South Africa, we don't have those many research, the many resources that we need, specifically because we do contract R&D. So when we make a product for a company, we do not license the platform that we are making the product on. We only license the specific product that we are making for you. So when we sit and we talk about what is it that you want and what are you targeting in terms of patients, what is the product going to be, the conversation is that we will license the product, but never the technology platform. And this is because if we were to license the technology platform, it would mean every time a client came to us, we would need to develop a new technology platform. It took us quite a number of years to develop each technology platform. As I said, even though the platform that I had was started in about 2021, but the technology platforms that we had were from previously work that we have done. So the platform technology that we use for thermostable insulin is one that can be used for many different biologics. You can use it for vaccines, adjuvants that are in vaccines. You can use it for other biologics as well. I already talked about the biomaterials for diabetic and chronic wound management. So this is just to show you that you can have it as a film, you can have it as a hydrogel. I talked about the nutraceuticals for diabetes support. One thing that I mentioned it quite quickly, we developed an anti-HIV filter for prevention of mother-to-child transmission. So here, just a quick story behind this. First, what we did is we developed it from RNA aptamers. So we developed RNA aptamers. They were already developed at the CSIR. We found out that they were selective to HIV. at the kind of technology that we've used for it. And then my last slide is just to talk about why formulation is important, especially for us in the African landscape. And we are developing drugs, and that's good. We do biomarker discovery. We discover different biologics, and that's good for us as a country and as a region. But who's going to use them? And is it important for us to just develop the biologics, or is it better for us to then think about what kind of formulation is going to go in? What would our users prefer? And what kind would we be able to manufacture the molecule that we've discovered once we've done the foundational research? And basically just highlighting the importance of patient-ready products and not just focusing on promising science. And that's my story. Taking questions?
Thank you, Doctor. Thank you, Dr. Ramalapa. Our next speakers for the day are Mr. Frank Mazibuko and Ms. Melissa Govender. Mr. Frank Mazibuko currently serves as a research management specialist within the Strategic Investment, Innovation and Impact Department at the National Research Foundation, where he provides support in the management of DSTI, NRF, National Institutes for Research and Development and Innovation. He operates within the Centers of Excellence, National Institutes, Research Infrastructures, and Flagships. Frank holds an undergraduate degree in chemistry from the University of the North, an honors degree in polymer chemistry with a focus on high-density polyethylene, and an MPhil degree in science and technology studies from Stellenbosch University. He began his career at the NRF as a license officer within the International Council for Science, where he served from the years 2005 to 2007. Thereafter, from 2007 to 2013, he worked in the Knowledge Advancement and Support Directorate, previously known as Knowledge Fields Development, serving in various roles and supporting multiple funding instruments. In 2013, he then joined the Research Chairs and Centers of Excellence Directorate, where he served until 2014. On the other hand, Ms. Melissa Govender is currently a research management specialist at the National Research Foundation. Her current portfolio includes the Centers of Excellence and Human Capacity Development within the Strategic Investment, Innovation and Impact Department. While new to this role, she has spent over a decade at the NRF working in various departments and across numerous funding instruments. Her experience ranges from science communication and engagement to grants management related to next generation scholarships and emerging researchers grants. I would like to call to the podium Mr. Mazibuko and Ms. Govender.
Hey, good morning, everyone. Thank you, program directors, and to our Unisa colleagues, thank you so much for the invitation to present on the NRF and some of its funding opportunities. It is an honor to be here today and to speak to you. So my colleague Frank and I, we are both research management specialists at the National Research Foundation, and we are part of the Strategic Investments, Innovation and Impact Department. You can call it SIII or SIQ. So today we're going to talk to you about our centers of excellence as well as our National Institutes for Research, Development and Innovation. So at the NRF, our mandate is to contribute towards national development, and we do that primarily through research and human capacity development. And in terms of our SIII department, we implement this mandate by advancing strategic investments, such as our SACHIs, which are our South African Research Chairs, communities of practice, centers of excellence, national institutes, as well as research infrastructure. With our SACHIs, COEs, and our NERDs, as they're called, all of them have a component of human capacity development, and this can be in the form of postgraduate support, postdoctoral fellowships, as well as staff development within those centers. We also focus on innovation in terms of embracing new technologies, as well as impacts. And impact is knowledge impact, societal impact, as well as environmental impact. So what is a center of excellence? A center of excellence is a physical or virtual research entity that brings together research capacity that is already existing, whether it's national or international. And it allows for collaborations to be created on long-term projects, and it also allows for capacity development. And when we talk about excellence, it's about joint goal setting, intra-organizational communication, extramural collaborations, interaction between scientific colleagues for productivity, and funding outcomes using fund acquisitions. Now, when it comes to a center of excellence, it's important that you understand that it is a planned, strategic, long-term research entity. Our centers of excellence can run for 10 to 15 years. So that's what we mean by long-term. So the centers of excellence were established in 2004, and we can either support a center of excellence from a top-down or a bottom-up approach, which means that the DSTI can come to the NRF and say, we want to run a center of excellence in a specific niche area. And then we can put out a call for universities to apply. Another way of doing it is that we have stakeholders who come to us and say, we have this idea of a center of excellence. And then we can get all the stakeholders, the relevant stakeholders together and try and put something in place if budget allows. When it comes to centers of excellence, the budget that we're looking at is from 8 million to 18 million rand a year. So it is a huge investment, and it is quite a big model. When the call goes out, there's minimum requirements that have to be met and other criteria. Conditions of grant is signed. There are other documents that have to be in place as well. We have various stages within the evolution of a center of excellence, from performing, storming, norming, performing, and then exiting. So it is a contract that will come to an end, so there will be exit processes as well. We are encouraging our current COEs to look at the sustainability. DSTI NRF funding will come to an end. So it's important that if the center wants to continue, they need to look for other sources of funding, leverage funding, other ways that their projects can continue beyond the contract end. In terms of objectives of a center of excellence, I have mentioned some like collaboration, scientific excellence, interdisciplinary research. When it comes to key success conditions of a center of excellence, some are listed there, like effective governance, acquisition of funding, international commitments. Just to talk about the effective governance, a COE is not just run by an institution. A COE has a director, it has a manager. Those two run sort of the daily activities of a COE. But it also has a scientific advisory committee. These are independent researchers, experts in the field that can guide the center in terms of its strategic objectives. We then have a steering committee. Now, the Scientific Advisory Committee and Steering Committee are two different committees. If a person is part of the advisory committee, they can't be part of the steering committee. They are both independent. And your steering committee will be responsible for things like the business plan, service level agreement, etc. And they will guide the research projects which will contribute towards the strategic direction of the Center of Excellence. In terms of the key performance areas, we're looking at obviously research, education and training, which goes back to the human capability development, networking, information brokerage, so things like science communication, science engagement, and service rendering, so influence on policy, for example, the production of patents. So as I said, the COE started in 2004, and these are some of the old centers of excellence that have now come to an end. We currently have 8 active centers of excellence in the country. We have Genus, which is the Center of Excellence in Paleosciences, Chimera, which is the Center of Excellence for Integrated Mineral and Energy Resource Analysis. We have Food Security, CIKS, which is the Center for Indigenous Knowledge Systems, SciSTIP, which has to do with scientometrics and science, technology, and innovation policy. We have Human Development, we have HIV prevention, and we have Mathematical and Statistical Sciences. So if any of your research projects fit into any of these COEs, you are more than welcome to contact me and I can put you in touch with the relevant COE directors and managers. So this is what we call our brag slide. So this tells you just the impact that the COEs have had over the years. In terms of collaboration, we work across all higher education institutions. We have collaborations in Africa, international collaborations of over 1,000 institutions. Participants within the Centers of Excellence have attended more than 900 seminars and workshops, and this is both locally and internationally. There's patents, human capital development, social responsibility, there's commercialization, where there have been 2 spin-off companies, and there's, of course, knowledge generation with over 11,000 peer-reviewed journal articles being published. Just to touch on or go a bit more into the human capital development. At the NRF, we have the postgraduate scholarships call, and the master's and doctoral calls are open at the moment. So whether you want to be linked to a COE or whether you want to apply for funding under a general scholarship, please note that the calls are open for master's and doctoral. They will close in July. In July, honors applications will open, and those will close in November this year. So please make sure that you apply in order to stand a chance for funding in 2027. So going back to our COEs, that just gives you an idea of the lifespan. So we do have all 8 COEs will be coming to an end within the next 3 years. So as it currently stands, there are no new calls open for Centers of Excellence applications. And we hope that once budget does become available, that we will then put out a call. Just to also touch on our longitudinal impact study, we will be conducting one for our SARCHIs as well as our COEs to establish its impact. And we hope that that study will be a positive, will provide positive results and will result in the continuation of the Centers of Excellence funding instrument. So now I'm going to hand over to my colleague Frank. With the Center of Excellence, it can transition into a national institute. However, it's not guaranteed. It is something that is driven by the DSTI and is dependent on the need in terms of our country's strategy. For example, our COE NITEP, it was the National Institute for Theoretical Physics. It actually transitioned into an official national institute of theoretical physics, theoretical and computational sciences. And that process took about 3 years. So it's not something that's overnight. It's something that just does take a lot of time. And Frank will tell us about the National Institutes. Thank you.
Good morning, colleagues. I'm just going to continue from where my colleague ended. to provide you with understanding in terms of how the COE actually transition to become a national institute. As she has already mentioned, that actually the COEs, what happened is that they only use what we call the legacy capital, which means it's the intellectual, human infrastructure, human resources infrastructure, as well as collaborative legacy that has been leveraged by the COEs. Then they can utilize that into forming something new, such as a national institute. So a COE can become anything else after its lifespan. But what we need to understand is that it comes to an end. They are not meant to be funded in perpetuity. So it then depends on its maturity, if it has matured beyond academic excellence, and if in the sector there is a need, it is still relevant. Because remember, they were set up to address certain challenges in the country, and some of them, after they've addressed that, then they become so obsolete, and there's nothing that they can offer or they can contribute towards. Though they still remain relevant in the national system of innovation, but for the purpose which they were created for, you'll find that they become so obsolete. So what happened is that then through the government, from the Department of Science, Technology and Innovation, then we will get a directive whether this particular COE needs to go through a review. And when it goes through that particular review, then we will determine if it has been matured. But remember, the Centers of Excellence on their own, alone, they cannot form a national institute. The National Institute is a consolidation of important RDI programs in the national system of innovation, which those RDI programs would be such chairs, would be National Institute, even probably some of the entities that were formulated by the science councils. When they consolidated, then they can form or establish what we call the National Institute. So what does the legacy capital include? It includes research, reputation, and national standing. It includes trained postgraduate students and postdocs. It includes established researchers networks. It includes international partnerships, and it demonstrated strategic importance to the country. As we have already mentioned, one of the most important things is that the National Institute is not just a rebranding exercise of a center of excellence. It's something completely new, but it is being formed or established based on on the legacy capital of the centers of excellence. I'm just going to explain about the National Institute. What are they? We mean that they are scaled up entities of the government. The consolidation, as I mentioned, of important RDI programs, such as the COEs and such chairs. These ones are long-term, prestigious strategic funding instrument. They ensure that research that is conducted is relevant and responsive to the country's developmental challenges. Formulating research agendas that address developmental challenges in respective RDI areas. They're creating possibilities to share research infrastructure, knowledge, and know-how. The key design principle is that they're building on positives, consolidating of RDI capacity, coherence, and they must be aligned to the existing national policies, such as the decadal plan, which is currently the overarching policy in the NSI in South Africa. This is just an illustration of how the National Institute is being formulated. As I mentioned, that is a consolidation of important RDI programs, such as the COEs, the research chairs, as well as other RDI entities in the country. How are the COEs, the National Institute currently are being implemented? This through an open call. We firstly post a call for the expression of interest, and then every university or research institution that is recognized by the NRF is allowed to submit their application. So, but because of the importance in terms of the area that they're addressing, with the current tool that we have, which is the NITEX as well as IPQ, which I'm going to come into details about them, what happened is that we have encouraged the universities to form a consortium and submit one consolidated proposal and make sure that all the key stakeholders are involved in that particular. So what it means is that the stakeholder survey exercise is very important when you have in mind or you inspire to become a national institute. So in preparing for the proposal, the person who's preparing that must have an end goal in mind. You must know who you actually representing in the system. Are you representing yourself? Are you representing your institution? Or you're representing a national strategy? And it must be focusing on impact. It must be an impactful kind of a proposal that is to be submitted. And it must be of high quality proposal, and which go through an expert evaluation, focus on public interest, must be a sophisticated project scope. These are the two that I was speaking about, which are currently existing, which is the National Institute for Theoretical and Computational Science. NITEX initially was NITEP, which was National Institute for Theoretical Physics, but now with an incorporation of computational sciences, it has transitioned to become NITEP. And then we have the Institute for Preparedness and Prevention of Pandemics, which this one was informed by the disaster that we find ourselves in as a country in 2020 with the outbreak of COVID-19. And then the government felt that we need to be ready and prepared should the next pandemic hit the country. Hence, now we have established this one. And then NITEX, it is hosted by the Stellenbosch University, and IPCubed is hosted by University of Cape Town. And then in terms of funding for these entities, it's core model funding, in which the government, through NRF and DSTI, we provide the funding, and the host institution is expected to provide a commitment funding, which normally becomes the 10% of the grant that we're giving to them. And currently, these two entities are funded between 38 million and 60 million per annum, which is such a huge investment. And I need to mention this. These entities, together with centers of excellence, they've been very successful in terms of leveraging funding. We have one which has now come to an end under Melissa's portfolio, which is called Center of Excellence, CBTPR, Center of Excellence in TB Research. We used to give them 11 million rand, but every year they will leverage about 140 million. That exclude publication subsidies. And then with subsidies, they will probably at most leverage more than 120 million only on publications, because those guys used to publish something like about 300 peer-reviewed publications, which are DHET accredited. And also, as we know that these entities, through the postgraduate training, the completion of degrees, the graduation of students, they also get the funding which normally goes to the university that is actually training those particular students. And then, so I'm going to move from this slide, but let me just touch a bit on an important part on this slide, which our keynote address speaker mentioned, the importance of inclusivity. In the National Institute, we prioritize that a lot, and we say the work that is done must be multi, and transdisciplinary, which actually we have to accommodate the key stakeholders in the sector. Yes, now I want I thought it would be very important to explain to you or to provide information to understand the difference between the Centers of Excellence and the National Institute in terms of the purpose. With the Centers of Excellence, their purpose is that actually these are time-bound strategic research programs, which are established to build national capacity in terms of research. They advance high-level knowledge production, they strengthen postgraduate training, and they create collaborative research networks. While else on the other side, the National Institute, these are the national entities which address strategic national priorities. They coordinate large-scale RDI activities. They support innovation, industrialization, and policy implementation. And then in terms of the characteristics, the COEs, as I said, they are program-based and they are time-fixed, whereas the National Institute are actually permanent entities. And these are long-term national mandates. The COEs are hosted by universities. While on the other side, the National Institute, these are independent statutory bodies. And then in terms of funding, the COE funding is competitive public grant funding. And in the National Institute, the funding it's funding that is baseline, which is parliamentary aligned funding. And then in terms of the strategic role, the centers of excellence, they develop emerging national research strength, they incubate expertise and collaboration, build intellectual and institutional legacy capital, as I mentioned earlier on. They often serve as the precursor to a larger entity such as the National Institute. Whereas the National Institute, on the other side, they provide enduring national capacity and capability. They coordinate research, development, and innovation ecosystem. They support industrial competitiveness and socio-economic development, and can evolve from the legacy of a COE to become a national institute. And currently, from the decadal plan, we have a number of national institutes that are on the pipeline, which still need to be implemented. The two that I've already spoken about, the NITEX, which is already happening, and IP3, which is also already operational. And then we have the National Institute for Poverty, Inequality, and Unemployment, which is going to be the next one that we're going to probably post a call probably by next year. We currently still with the conceptualization of this one, as we believe that this is one area that actually includes everybody in South Africa, and it affects everybody. And therefore, we need to make sure that the stakeholder survey exercise is done accordingly and appropriately. And then we have the one in Indigenous Knowledge-Based Bio-Innovation Institute, which currently the COE that Melissa mentioned, a COE in Indigenous Knowledge System, is currently undergoing transition to become this particular national institute. And then we have one on health-based cancer institute. We have one on polar research. And then we have the potential additional institute of applied human and social sciences. And then we have the science, technology, and innovation observatories, sorry. And then we have the three that we are still engaging with the department to understand if there is a need to establish one on water, the energy, as well as biodiversity. Because initially with water, the department was actually of the view that we need to establish a mega COE, which is going to serve like a national program with entities such as other COEs supporting it, as it's a cascading kind of an initiative. And this is our last slide. And I would like to say, thank you so much, colleagues. Thank you, Program Director, for your time.
No speakable content will be found on the screen.
No problem, Dr. Sia. Thank you to Mr. Mazibuko and to Ms. Govender for their presentation. Moving on with our program, we have Dr. Siyabulele Ntutela. He is he joined Unisa, Directed for Innovation, Technology, Transfer and Commercialization at Unisa in 2025 to facilitate the commercialization of technologies and research outputs. He is also the Managing Director and founder of Intini Research and Consulting, bringing expertise leadership roles across diverse sectors. Dr. Ntutela served as the Executive Vice President and as the CEO at Africa Bio, an independent non-profit biotechnology stakeholders association focused on providing accurate information and creating awareness of biotechnology and biosafety in South Africa and the African region. Did I get that right? Great. Lastly, his experience extends to the international stage, having served as the deputy chair at the International Council of Biotechnology Associations in Washington, D.C., USA. This is an international council promoting and advocating for the biotech innovation in human health, agriculture, and industrial environmental sectors. He served as the ambassador for Life Sciences Queensland as life sciences industry body in Australia, fostering growth within the life science sector. Take it away.
Thank you.
Next time I'll make sure that it's very short and you don't have to read the whole thing. Colleagues, good morning. You've heard what my name is, and I will be very brief. My role is just to tell you about a certain directorate within the University of South Africa, Unisa. I'm not going to be talking about good science. There's no money. And so please, if you feel like falling asleep, just stand up and stretch yourself and listen again. So the DITTC, Directorate for Innovation, Tech Transfer and Commercialization within the University of South Africa. What do we do? All right. So I'll start by bringing in the context to why we were formed. In 2008, our government passed in the act, which is called the IPR Act, Intellectual Property Rights for Publicly Financed Research and Development Act in 2008, which basically had three pillars. If I were to summarize it, one is identification of IP produced within the Republic or financed by the Republic, the protection of that IP, and the development and commercialization of that IP. Now, out of that, the purpose was to create value, coming out with innovative products that our system, our government system, our public systems, our private system can come up with that will have an impact in our lives, creating a space for shared benefit within the IP that we produce, which is financed by the public, and creating new sources of economic growth, obviously using innovation as a key to that, either through technologies that are coming from research or through processes and services that would then increase efficiency in our activities. Out of that act, there was a demand, I'll put it as a demand because the Act of England demands those that are complying to it to adhere for the establishment of technology transfer offices within all publicly financed institutions in the Republic. Now, in the case of Unisa, we called it the DITTC. I'll call it we because I'm part of Unisa, even though you've heard that I joined last year. We established the Directorate for Innovation, Tech Transfer and Commercialization. It's basically, in a very short description, the tech transfer office of the university, but we do more than just tech transfer. We call ourselves the custodians of University of South Africa's IP. We're enabling partner to a research community, to colleges, to you as researchers for effective tech transfer and commercialization of all the IP that comes out from what you do. Now, as a directorate, we've got multiple functions, which is why I said we do more than just tech transfer in a classical form of it, all right? And I'll talk you through some of these, and I'll spend more time on this slide and the one that comes after, which then explains directly what we do. We have a function that we call the Unitech. Basically, within that function is where we deal with invention disclosures that come from researchers. I'll tell you about what that process is all about. We do IP protection from university research activities. We create awareness throughout the university and within the environment of the university on what is IP. As you might know, that we run programs that not only for our university community, but also anybody who's affected or within the Unisa community, which is our industry partners, our community members, and so on. All right. We deal with issues of licensing and compliance, which must be done by the university in compliance with the Act, and also interact with the Department of Higher Education and Training on issues related to technology transfer, IP from the university. We have what we call the Unilink function within our directorate, which its role is to make sure that we interact our university community with industry players, what we call the impact multipliers, identifying potential partners that will work with us as a university to make sure that the research that comes from Unisa has an impact in society and in the industry, and to assist some of our researchers who want to do contract research using Unisa's IP. We have the UniVentures function, where we work with a number of student startups, academic startups, alumni startups, by creating what we call a startup academy, training all of our researchers on how to manage your startups, our students and our alumni, what to do when you establish startups, how to link you with potential funders, and how to link you with potential markets of your startup. But more to that, we also do a lot of trainings within the UniVentures for everybody within the universities on how to run your own business, how to start your own company, how to manage it, how to identify the customers, and eventually how to make sure that your business is sustainable. That is what we call the UniVentures. Now, we have a function called the Univest, where we then assist with raising funds for commercialization of our technologies, for commercialization of your own startups as university communities. Bear in mind, this is not only for research that comes from university. There are certain students that have come to us as a directorate that says, I have this startup that is technology-based or that is process-based, and can you assist us? We then link them up with a number of different funders that are within the ecosystem. We work with a number of funders, the Technology Innovation Agency, the NRF, and others, to create what we call the seed fund base for Unisa, which our intention is that it will lead to what we call the Unisa Innovation Fund, where we get a number of funders, pull those funds together, so that whenever there's a good technology that comes from our university, we can fund, or there are good processes or good business activities that we think we want to fund. We run innovation challenges around campus. I'm sure if you're a student, you probably know that is an active one at the moment in time, where we just call out any student who has an innovation. We do a pitching for them, and eventually those that win, that have a very good innovation, we fund them. We don't own the IP, it's a student's IP, but we assist our students to be creative, to innovate, and to come up with new products, processes, and services that can have an impact on society. We also run innovation challenges for our alumni. If you've started Unisa and you're no longer here, but we have an innovation that you think you want to be funded in, we are currently running what we call the Unisa Pioneers Challenge, where all our alumni, they come to us, they pitch our ideas, and working with the Unisa Foundation, we then support those setups and linking them to funders, linking them to markets, and so on, because the idea is that we want to make sure that Unisa is an innovative ecosystem and is built by technology that come from us, and working with industry to make sure that it happens. As I said, we run a number of innovation challenges. I won't talk about them now, and they've been all over your emails. I'm sure you know about it. But more importantly, we make sure that Unisa's innovations are marketed accordingly. There's no point in us working if we cannot market what we do. So we have a very strong marketing function that makes sure that all our technologies are marketed accordingly. We create your knowledge, create knowledge about what it is that the university does through exhibitions, through linking up with international partners, and making sure that we publicize the work that is done at Unisa. Now, how do we do our work? Again, as I said, I'll spend again more time on this. On awareness, we run what we call master classes, innovation science master classes. I think there's some that are going on now where we invite strong industry leaders on certain topics on innovation. They come and teach our community about what it is that they're talking about. It's more about innovation or IP or how to commercialize your technologies. We do road shows to different colleges of the university, like I'm doing now. Again, the essence of this is that we want to make sure that every member of Unisa knows how to manage IP, knows what resources are available within the university to make sure that whatever you do, there's support that is needed, that's available for you. And if you want to patent your IP, where do you go? If you want to raise funding, how do you do that? I talked about the Innovation Leadership Series, where we invite leaders just to talk about innovation broadly. There's one that's coming out, I think towards the end of June. Tomorrow is a World IP Day. We will be having a series of speeches on IP. And I think, if I'm not mistaken, it's going to be on IP and sports. What do we do when it comes to IP in the space of sports? And in November, we run the Innovation Festival, which again is a platform for Unisa to showcase its own innovation from students, from researchers, and even in that innovation festival, we also run pitching sessions and competitions where whatever you've been doing throughout the year, we then announce the winners of all those funding instruments that we've got through the pitching program that we've got. We run capacity development programs at Unisa, sometimes only at Unisa, but also in partnership with other organizations. We do it broadly through the community of innovators in South Africa. We have what we call the Uptech boot camps, where we take our students, our staff, alumni on a week-long boot camp on how to start your business, how to run your business, how to manage your business. And out of that boot camps, we then come up with a business plan that we then submit to Unisa for whether it's for funding or to whoever the partner that we partnered with for funding. In last year, we launched what we call the Winnovate, which is Women in Innovation, which was a very great successful activity. The program behind Winnovate was that we want to recognize the role that women within our community play in innovation. And we had industry leaders that are participating in that, and we're going to have one again this year. We want all the women leaders and innovators within the Unisa to be known because, again, we know statistics have shown that most of these innovations, we seem to think that they come from us as men, but there's a lot of work that is done by the women in our societies. So we wanted to showcase and celebrate that more importantly. Innovation Fund, I've spoken a little bit about that, but we run a number of these programs as Unisa that we're trying to get funding from different instruments, different entities and different organizations throughout South Africa that will then support the innovations that you as researchers, as a student, have within your research groups and laboratories. Last year we had a Tshwane Higher Education Challenge where they wanted to find solutions on issues of energy. Unisa students participated in that, and we're going to have one again this year. We launched the Eastern Cape Innovation Challenge last year, where again, where we called all Unisa students within Eastern Cape to come up with ideas that could solve problems in the Eastern Cape, and whoever won out of that got some award, and which we'll intend to continue with all of those innovation challenges. So we call upon you as leaders, as students and researchers within CAES to look out for those, and if you have ideas that you may have, to stand up and bring out those ideas to us as a directorate. I've spoken about the venture business support program within UniVentures, where we assist our startups to launch themselves and to launch their businesses. We also run very strong international exchange programs. As I speak now, we have about 10 students that we've sent to Switzerland, basically to just go and learn about innovation. They are innovators from Unisa, students and staff that we've sent to Switzerland to meet their counterparts on the other side, learn how to pitch, learn how to raise funds, and learn how to launch your startups. There's a number of them to the US, to Babson College, to MIT, and other countries. The idea behind this is that we want our students to be known globally, but also to learn from those that are there behind us who've been doing this work for a number of years. So we've partnered with MIT just recently, about 2 months ago, through their venture mentoring program, which is aimed at supporting Unisa to mentor our startups, our ventures. And that is a global program that MIT has launched, and Unisa is now one of the 6 startups behind that MIT program. And we will be launching it soon within Unisa for all the startups that we form in the university. And commercialization, I'll talk about commercialization later as I proceed. So those are the programs that we host within the DITTC. Now, the question that you'll ask is, why do we need to do tech transfer as a university? Most of you know how to publish papers, but the question is, why do we need to do technology transfer? Why can't we just publish and pass and get degrees? I liked the slide when I first saw it. This is what the public expects us. Governments all over the world, they pump in a lot of funds into R&D. We as researchers, we know what to do. But there's someone who is in the streets of Soweto, of Etsomo, or wherever, who wants to know why so much money is going into R&D and not into into social development activities, which means that the public is expecting something to come out of this machinery of R&D. And through tech transfer offices, this is how we need to convert the research that we do into products and services and processes that would benefit the public. That is why we do tech transfer within universities. As I mentioned earlier on, it is a process of commercializing academic research, putting innovations to use for public good. That is called tech transfer. I will emphasize on the point of commercialization. People think that when you say commercialization, we mean money coming out. It is not always the case. Sometimes it is value to those that are getting the products. It doesn't always have to be profits. It sometimes can be bring a technology to a community that needs it at a zero cost to them, but at a cost to you as a research institute. In that way, you've commercialized it because someone has made use of that technology for their own benefit or to improve their lives. I'll skip the definition. So the process behind, which is what we use at Unisa, is that as a researcher, you do the knowledge generation. You come up with a very good idea. That idea can be used to produce new products and so on. But what we do is that we assist you to fundraise for your product. We assist you to protect your IP. And as I mentioned earlier on, we assist you to market your research so that it has value to the society and to communities. And at a certain point in time, when that research of yours has value that can be converted into product, we either assist you to form a new company or to start to take that technology and infuse into existing commercialization. That is the broader process of tech transfer. Narrated in words is that you are a scientist, you disclose your innovation or invention to the university, and then we then assist as a TTO to evaluate whether is this novel, is this new, has it been done before, can it be protected? If it is protected, we do then the process of protection. It can be a patent, it can be a copyright. There are many forms of protection of IP. I don't want to say only has to be a patent. Not all IP can be patented, all right? Then that process all follows until we get to a point where we commercialize your technology. Either we change your license or an existing company, which is what I'm going to talk to about. But importantly so, which is what I want to focus on for you as researchers and students within CAES, is what we call the disclosure stage. This is very important. We emphasize, and we are required by law, the IPR Act, to protect university IP that is funded by the public press. And the starting point of that, after you've done the research, is to disclose your inventions. After that, you can then will do an evaluation and everything, but it is very important that you disclose your IP. Why do I say it's important? How do we do it? Now, at Unisa, the DITTC has what we call the invention disclosure form. You are required as researchers that before you go and publish and send your CV, send your thesis to whoever, if you identify that this technology that I've come up with, this process that I've come up with, or this new ways of doing things that I've come up with is the first of its kind, you then approach the DITTC and you say, I have this invention. We'll give you the form. This is just a snippet of the form. We'll give you the form to then populate that. The reason why that is important is that if we then discover within a very short period of time that this that you've discovered is new, we immediately launch a production process, either through a patent or however it is that we do within the South African Patent Act, all right? So that when you go and publish somewhere else, we know that you are the first disclosure of that information. Because if you go and publish something that is novel, you can never publish, you can't come back and then want to patent it. You've lost that patent, and the Act requires us to protect the IP that is funded by the public press. Hence, we emphasize that once you as a researcher have come up with a new invention, you approach the DITTC and will assist you with an invention disclosure and the protection of that IP, or at least the right format of being the first disclosure of that invention, all right? Over the years, it's just the history of what we've done over the years. The DITTC was formed in 2014 or 2013, somewhere around there. And as you can see, there's been constant growth in the number of IP disclosure that will come. In 2010, there was a decline because of COVID, but last year, 2025, we had about 25 disclosures. And out of that, we had launched, or at least our patent applications were 54, which is huge. If you come to think of an institution like us, which is mainly long-distance research institution, we were 54 patents. We also recognized somewhere in the middle of last year that actually Unisa has surpassed 100 patents over the years. I'm sure if you do the mathematics, you'll see that actually, which is a milestone that we wanted to celebrate last year. So hence we emphasize that if we have these new disclosures that we want to do and we want to patent, it adds to the value. Now, how has CAES done over the years, or at least last year? There were 40 disclosures that were reported to the university. Most of them came from CSET, but CAES was not bad. We had about 7 of those, very good disclosures, and we are hoping that this year you beat that figure of 7, you get to a higher figure than 7. Again, the importance of this is that we want to make sure that you protect the university's IP and you don't disclose it unnecessarily. Now, coming to the second stage of commercialization, what happens then now that we've disclosed your IP? The DITDC supports the university to make sure that your IP is commercialized, if it's commercializable. Not all IP is commercializable, but it is commercialized. Now, how do you define what commercialization is? And I've mentioned before, it's a process whereby you take an idea and create what is called financial or socio-economic value of that, okay? There are multiple routes in which we'll do that. I'm looking at time, and I'll be fast. There are multiple routes that we as a DITDC follow. There are 2 routes, basically. You can either commercialize your technology through licensing, where we identify that what you've done or what you've discovered can then be given to another company to then create or use in their own processes, which is what is called the licensing part. Again, this is done by DITDC. There's a number of economic assessments that we do on whether should we commercialize your license through an IP or sorry, to your IP through a license, or should we form a startup? The other part of it is that the formation of a startup company, which is that you now want to take your IP and you want to spin out a new company, which is what we call a spin-out formation. You can spin out or a spin-off, whereby you then decide as a research group or someone within a research group that we want to form our own company using our own innovation, and you will take some members within your group that will then go and run that because you know the technology. All right. That again, the DITDC's role is to then assist researchers to be able to then say, if you are to form a spin-out, how do you do it? Remember, you don't just decide to form a spin-out. There are multiple considerations that you must take, and I'll take some of them quickly. Is that you need to consider, if you are forming a spin-out, are there staff members within your team that are prepared to then leave the university desk and go and form that company and run the company? Or are you going to use your time within the university, but you must do it in the right manner by approaching the university so that you can be able to know that the time that you're paid to be on the laboratory is not now used to form your own company. Negotiate, and we are allowed to do that. That is time spent in the company versus time spent in the university, right? The Act allows for benefit sharing amongst the members. It's prescribed in the Act that if you're an inventor in a technology, there's an amount of money that is due to you when it is commercialized, and we can't change it as Unisa. We can change it up, but we can't change it down, all right? And you also need to consider who are the board members that will form part of your startup. All of those activities, you talk to the DITDC to assist you to put all those systems in place, so that once you form your startup, we know that you are not forming a startup that's going to die and eventually lose our technology. Again, in most of these cases, the university may decide to take equity in your startup, and I'm saying may or may not, right? I will stop there in the interest of time, and if there are questions, but I know there are no questions, but that in a nutshell is what the DITDC does, and we encourage you to get in touch with us. If you do not know how, there's our email, the direct email that you can write to us. innovations@unisa.ac.za will then answer any question that you have. But more importantly, that is also what you can use to disclose your inventions. And if you have an innovation that you think you want us to support, talk to us about it and we'll be able to support you in all the ways that is possible. Thank you very much.
Thank you, colleagues. We have officially come to the end of session 1. We are going to, in the interest of time, we are going to take a 15-minute comfort break before we start with session 2. There is tea outside, and we also have our industry partners showcasing outside. Please interact with them, and the time is almost 11:30. Can we please meet again at 11:45? Thank you. Good afternoon. Afternoon, welcome back, everyone. Can we please sit down while we start with session 2 for the day? Thank you. Our session 2, which is titled Overview and Showcase of CAES Research. The aim of this session is to provide an overview of the research activities and innovation taking place within the College of Agriculture and Environmental Sciences. It also serves as a platform to showcase current research initiatives, promote knowledge sharing, and highlight the contributions of CAES research towards addressing societal and environmental challenges. This session will also demonstrate how the college continues to align its research with this year's theme, Unisa's catalytic niche areas powering change through impactful and solution-driven scholarship. Our first speaker for this session is Professor Vahangwere Masindi. Vahangwere Masindi is a goal-driven distinguished professor from the University of South Africa. He has vast experience in water resource management, environmental engineering, and environmental sciences. He is also the subject editor for Water SA Journal and board member of Environmental Science and Technology under the ambit of American Chemical Society, Earth Critical Zone under Elsevier, and Minerals under the MDPI. Furthermore, he is on the list of the world ranking of top 2% scientists from 2021 to date. Specifically, the principal focus of Prof. Masindi is grossly underpinned on wastewater treatment, water quality, water security, ecological sustainability, wastewater valorization and beneficiation, and environmental pedagogies. He has progressively developed, piloted, and implemented various technologies in wastewater treatment and waste valorization in the urban, peri-urban, and remote setups. His main quest is to foster circular economy, zero liquid emission systems, sustainability, closed loop systems, and waste beneficiation. He endeavors to inspire circularity, ecological sustainability, and green initiatives in wastewater treatment to achieve international, cross-national, national, and regional priorities and objectives on the entire value chain of integrated water resource management. To date, he has published over 110 scientific papers in top-tier, high-impact factor, and prestigious journals, and filed 5 patents through the Patent Cooperation Treaty in wastewater treatment using novel nanostructured materials. He is a recipient of numerous awards, such as Emerging Researcher Award from the CSIR in 2017, the National Science and Technology Forum in the National Science and Technology Forum in 2019, Innovation Award from the Department of Science and Innovation in 2019, Regional Young Scientist Award, Scientific and Technological Achievement in Engineering Sciences in 2022, the Captain of the Industry Award from Magalies Water in 2023, the National Order of Mabungube in Bronze from the President of the Republic of South Africa in 2023, the Water 2024 Young Investigator Award from NDPI, the winner of 2025 World Young Sustainability Award from Sustainability, and the 2025 Unisa Chancellor Award. He is also the DSTI NRF Statutory Holder on Integrated Water Resource Management. He is also leading the Consortium on Water Resource Management and Center of Excellence for Integrated Water Resource Management. The stage is yours, Prof. Thank you.
Colleagues, good morning. I think I've been introduced. I'm not going to introduce myself again. I don't know if we can flag the presentation. Okay, no, thank you very much. I'm requested to briefly talk about our Center of Excellence in Integrated Water Resource Management and different research agendas that we are pursuing from our end is the Center of Excellence in Integrated Water Resource Management. We also have a SACHI chair in Integrated Water Resource Management that has been given to us by the DSTI and National Research Foundation. And also within the college, we work within the consortium of water resource management on the entire college, where we agglomerate or attract everyone who's focusing in water research, whether it's water treatment, water monitoring, waste valorization from wastewaters, different wastewaters, be it acid mine drainage, be it municipal wastewater. Within the auspices of the College of Agriculture and Environmental Sciences, specifically the Department of Environmental Sciences. This is how we pursue research and how our research borders with different frameworks within the college. We align the integrated water resource management to different CNAs, which are the driving strategic framework of the University of South Africa, as endorsed by our principal. I don't know, the screen went blank, but we border ourselves to the college strategy and also the Unisa strategy. We also align with the National Development Plan. We also border to the African Agenda Aspiration for 2063, and lastly, the Sustainable Development Goals. There are quite a number of pillars that we align ourselves with, including the Partnership for the Goal as well. That's what we do, and where we sit is the Center for Integrated Water Resource Management. The research that we pursue in our domain, which is within the integrated water resource management, we cover everything in the entire water value chain, which is the water continuum. We start from the water reserves. Water reserves, we look into the rivers, be it the visible water or the surface that is underground, and also look into the interaction of surface water and groundwater, and also the managed aquifer recharge, whereby we have enough surface water, but we need to recharge the aquifers, whether the top aquifers or the deep aquifers. We look into that. We also go in the abstraction points for different entities that purifies water for distribution purposes, assist them on the purification technologies that they need to develop. Then we also look into the distribution network. In the distribution network, we have a lot of issues, mainly the microbial regrowth. We look into the booster stations, resistant microorganisms within the distribution network. Those are resistant organisms and the genomes that are available within that distribution network until the water gets used and dumped back into the environment. Then we cover the entire loop as the Center for Integrated Water Resource Management. I will show you some of the research that we have embarked on, which we believe are groundbreaking, are game changers in this fraternity of water resource management. These are some of the projects that we have done, which we believe these are pragmatic solutions. Here, what we're trying to do, we're trying to mimic the filtration gallery for drinking water treatment plants. These days, we have an issue of emerging contaminants. Emerging contaminants are novel contaminants that are problematic to the current systems, because conventional systems were designed to remove certain types of contaminants, but they were not designed to remove these types of emerging contaminants, including the ARGs. So we are mimicking the gravity system, where you have the granular activated carbon. Water comes from the sand filtration systems, it goes to the GAC system, then it filters through. So we just want to check the efficacy of different activated carbon. We generated activated carbon from the macadamia nuts. We used the hyacinth for the production of biochar, for the production of activated carbon, which we loaded into this column that we use for the removal of contaminants. We try all the algorithms. We even tried the upflow movement. We tried the downflow movement, check the efficacy, saturation level, and how often can we regenerate these materials that we have and what we produce. We tried it in different applications, in municipal wastewater, also in acid mine drainage. We have evaluated its efficacy and performance and checked robustness thereof. And this is another project in terms of water quality monitoring within the continuum of our interventions. So you can see we have a hypereutrophic systems that is infested by algal species. And down there in RTBS port dam, we have the hyacinth that covers the top of the water. It's a floating species that is quite problematic, and it hinders some of the biogeochemical processes within RTBS port dam. We have embarked into a groundbreaking research where we valorize these plants. We harvest them, We valorize them for the production of fertilizers. We valorize them for the production of biochar. We valorize them for the production of activated carbon. Then activated carbon is part of the downstream process. It's used for the purification of those contaminated water, for the removal of emerging contaminants or contaminants of emerging concern. And also we go to the bore to check to profile the water. We establish a sampling point or a transect within the dam so that we understand what are the topical contaminants within the water body, which algal species distribute within the water column. We can even go down as deep as 20 meters going down, sampling at 1 meter frequency going down the water column. And this is just an example of some of the colleagues harvesting the plants. On the other side is myself there. We're doing catchment monitoring. So I just want to demonstrate some of the research activities that we embark on. So the scope is quite broad from our consortium. But here I'm just taking a snippets of what we do so that at least you can get an appreciation of what we embark on. And if you would want to work with us or collaborate with us in this consortium, it should be much more easier because you understand what we are doing from our sphere of operation. And this is the nanobubble generator on the far right. This generator, we have introduced it in the RTB Sport Dam. We have done quite a number of applications. It has the algaecidal properties. Algaecidal in a way that it activates the algae that is available in the water body. It can be used for the remediation of algae, and due to its superoxide capacity, it has that ability to decompose the nutrients that are available. The ammonia can be decomposed, oxidize the metals that are available in the water column. So we're trying it there. We ran different assays within the laboratory just to understand the loading efficacy, the mass transfer, what are the hindering factors, and how we can optimize this technology. Here it's about the middle one. It's looking into the chlorine booster station. Chlorine booster, usually when you have long water distribution networks, you have the issue of microbial regrowth because chlorine is used to suppress microbial regrowth. But here we had an in situ production of sodium hypochlorite using different chemicals that we have established and an electrolytic process. Then we check the efficacy of this chemical that we have produced against the commercial chemical. Then we see that it's giving the desired output, and we know we were not having any microbial failures within the distribution network. And the indicator organisms were mainly the total plate counts, the E. coli, and the coliforms. Here I was just trying to demonstrate some of the issues that we deal with. This is groundwater. This is the top aquifer. You see the water is coming out black, meaning that the groundwater is not suitable for any use. If you run it for more than 30 minutes, this reservoir, the water gets clear. But with time, there's reddish color on this borehole. If you are using this water in a geyser, use this water for a kettle and everything, it forms crystals in the kettles. The geysers doesn't even last more than 2 months. We went there, we supported them. We came up with a technology to treat this water. So we had different stages or unit processes that we put in place to ensure that water is compliant. So those are some of the research that we do. And the quest from where we are sitting in our sphere of operation is to develop solutions that are inclined towards societal challenges, not just to do research in the laboratory, but they don't benefit the community. So those are some of the aspects that we consider, and we endeavor to foster the SDG goals, NDP. Hence I said we brought ourselves to those strategic frameworks. One of the projects I love the most is this one, which looks in the reclamation of acid mine drainage. You see this red water. This is acid mine drainage. Whenever there's coal mining, whenever there's gold mining, you go to the Western Basin, this is the reality if you go there. Water comes out of the shaft. It's colorless. After very few minutes, it goes red. And it gets into the rivers. When it feeds into the rivers, it contaminates the rivers. We have the heavy metals here, we have the zincs, we have the iron, we have the sulfate, everything is available there. So it's problematic. Hence you see groundwater here in South Africa, majority, especially in Gauteng region, it's not really suitable for consumption without any prior treatment. And people have been working under the wrong impressions. So we went into the field, we looked into this mine water. We came up with different technologies. First, we started with neutralization, just to neutralize using different alkaline agents. But we realized that we can optimize the intervention whereby we don't create another downstream, whereby you generate sludge that comprise heavy metals, then you have to dispose it into the landfill. So what we did now is to pursue the concept of circular economy, where you valorize all the minerals that you recover from acid mine drainage, sequentially so, checking different stoichiometry. So in this case, we reclaim drinking water. That system that you see, which is a pilot plant, it produces 20,000 liters of drinking water per day. That's what we have done. This is the algorithms that we have. Firstly, we started with one reactor, whereby you have a return stream. You put a neutralizing agent, you increase the pH, you remove the ions, you bring it back, you recover the gypsum, you bring it back, you soften the water. Because if water is not soft enough, it's going to scale your membrane downstream, whether you're doing freeze crystallization or whichever process that you want to pursue. Then this process as well has the capability to treat water that is fit for purpose. Sometimes you don't need to treat water for drinking purposes. You can treat it so that it's suitable for discharge. You can treat it that is suitable for a defined industrial application. You can treat it so that it's fit for irrigation purposes. Those are some of the terminal objectives that we pursue from our end. And if you treat it to discharge, the amount of money that you need to inject is less than the money that you would use to treat it to the drinking standard, because drinking standard, you need reverse osmosis processes, which are quite exorbitant in terms of energy. Then you need to inject more to treat water to that standard. And also out of this, we are able to recover rare earth elements. In all the iPhones that we are using here, rare earth elements are integral. This is the biggest market in China. We tried the extraction techniques, different extraction techniques to recover all those rare earth elements and efficacy thereof. The paper has been published in Hazardous Material Journal, and it's very much promising. It's something that we are upscaling. We have engaged different mining houses such as Sibanye Gold and Exaro, so that at least there can be the uptake of this technology. Hence, I said our technologies are inclined towards the industry, are inclined towards the society. We have sulfuric acid because pyrite is oxidized. There's a high concentration of sulfate. By the virtue of it being water, there's sulfuric acid there. So we just need to recover it in that way. Ferric chloride, sequential precipitation, we use it for the production of ferric chloride, for drinking water treatment, for wastewater treatment. Iron hydroxide also has the high capability to be used as a precursor for the ferrate, which is iron 6, which is a superoxidant. So those are some of the research that we are pursuing. Out of that superoxidants, you use it for the treatment of wastewater. Again, it has multiple purposes. It can be a very good coagulant, disinfectant, on all those things. Gypsum, we use it for the cupboards and everything. Those materials are made of gypsums and critical minerals, such as the aluminum and all that, which we use even for battery technology. And these are the sustainability of the COA. You can see here, it's a very big center of excellence. We have internal within the university from the CNA, they are assisting us. And also internationally, we also collaborate with international universities. And we have different facilities here within the college, and we collaborate with other industries and universities, and also the council such as the CSIR and its footprint in the industry, because these are students, they become ambassadors of the center. Hence, we train them to the level that they become a product of the industry. So these are some of the funders. We did stakeholder making. We looked into the potential funders, the water boards, the municipality, the mining houses. I'm sure you looked into the array of projects that we have. And this is the current funding that we have. We have the TIA funding, we have the Dawara C funding, we have the Sachiche funding for Tier 1, which is 3 million per year, which is, I think, one of the biggest in our group. And these are some of the publications. The first one is looking on the ARGs. Antibiotics are used every day, everywhere. So here we're looking into the temporal-spatial migration of ARGs in a wastewater treatment process. You start from the influent, you go to PST, BNR, SST, then effluent discharge. Then you check their migration and the efficacy of those unit processes in removing these ARGs in their systems. This is the paper that we published. These are all 2026 papers. On the other one is about nanobubble technology. I spoke a lot about its ability to remove algae, its ability to remove ammonia, its ability to be a superoxidant. So those are some of the research that we are embarking on. And from our group, we understand that as soon as you finalize or crystallize a research project, especially a review paper, out of it, you need to crystallize a very strong research project that you use for different funding agencies. And here you look into chlorine decay demand. We did waste management. This was for the CE project within the college as well. And these are some of the work on the trends that we did and challenges within wastewater and acid mine drainage. You can see all this 2026 and additional papers on the use of iron 3 for ferric chloride, and the book that we just published with Dr. Banza. Are you there? Yeah, we just published a book this year, so it's quite promising from our end. And lastly, the different filtration technologies. And I close with a patent that we have also filed. It's a PCT patent on the production of ferric chloride from acid mine drainage. We are doing a lot, and we have a student who is now in Switzerland, busy with this project. So we are engaging different funders, different incubators. We want to have a startup so that we can have the spin-offs. I love the presentation from the ITTC office because it speaks to what we are doing from our sphere of operation. And good news is that we might be launching this Center of Excellence in this financial year, which might be in September. We are trying to be synchronous to the World Water Days. Prof. Matala here. I think she proposed from there here. And yes, I see she's at the back. She's the Deputy Director of the Center of Excellence, and Dr. Radingwana is the Secretariat. And this is the team. We have myself, we have Prof. Matala, Dr. Radingwana, Prof. Tekere. She's quite integral. She has been my mentor when I started my journey as a researcher. We have Prof. Ngole, Dr. Mapangwa, Dr. Paloi. The list is long, including the postdoc, Dr. Panza and them. So this is the team. And I think in September, we are going to launch our Center of Excellence. And colleagues, you can join us. That's it from our side. Thank you very much.
Thank you so much, Dr. Cindy. Thank you. We have our next presenter who's going to be online. It is Prof. Chilele. So Prof. Chilele holds a PhD in botany from UKZN. He spent 20 years at the Agricultural Research Council, where he worked as a researcher and later served as the research team manager for range and forage. He is currently a professor at the pasture science at Unisa. His research focused on rangeland ecology and management, with particular emphasis on herbivore-vegetation interactions, as well as the factors influencing foraging behavior and the seed dispersal of woody plant species. He has played an active role in the scientific community, serving as the publication editor of Grassroots, the newsletter of Grassland Society of Southern Africa, and later the president of the GSSA. He has also served on the advisory board of the Center of the African Conservation Ecology at Nelson Mandela University, in addition to contributing to several other committees. Prof, can you hear us?
Yes, I can hear you. Please confirm if you can hear me.
Fantastic. The stage is yours, Prof. We can hear you.
Thank you very much. And good morning to everyone. And thanks for the invitation to share what we are doing. I just have only one concern, that is to present after Prof. Masindi with such an incredible work. But nevertheless, I must say from the bottom of my heart, you are setting the bar very high, and keep up the good work. But that as it may, colleagues, as I've been introduced, there is no need for me to introduce myself. Let me just get straight to it. I am currently in the UK attending some workshops as part of leveraging and also, getting some partnerships, and also exploring more funding, particularly from the European Union, and it's looking good. So as much as I'm not there in person, I think it is good that one is here. First things first, let me start by acknowledging the team. These are some of my colleagues, which comprise of postdocs, as well as Prof. Tamara from geography. And I'll tell you more about what we're doing and their role. But the reason why I'm starting here, it is, for me, everything starts with people. Anything else becomes a product of people, and therefore it is critically important, to acknowledge, colleagues, and the list is endless. And please, for those whom I'm not mentioning, please don't take offense, because we are still in the building process. Slide's not moving. This is not a mistake, colleagues. It is indeed a blank slide. And before I delve into the nitty-gritties of our consortium and the bush encroachment chair, there are times in life where you need to pause and reflect, introspect, and look at how one should approach problems. And this is because if we go at times with the speed that we are on, we miss some of the corners. And it is for that reason that, I'm starting here. But second is, I thought I should also paint a picture as I was preparing for this presentation in the context of the principal and the VC's catalytic niches. I also, listened and read a bit from what our Minister of Science, Technology and Innovation, Dr. Blaine Nzimande, is saying about the space that we're operating in, which I thought it will set the scene quite nicely before I delve into the finer details of our program. And one of the issues that he has mentioned is the decline in global competitiveness as South Africa. And this comes from the Global Innovation Index published in 2025 that says South Africa, has moved from 16 to 64 position out of 139, countries. And this has raised a question to South Africa, to various institutions, Unisa being part, but to also as academics and scientists to say, what is our role in ensuring that our global competitiveness moves to where it was and even gets better? Two, he raised the issue of, research and development investment in South Africa that has decreased basically from 0.76 to 0.61 as a percentage of the GDP. And this is against a target of 1.5, which we are supposed to reach as a country by 2030. And that means in the remaining 4 years, we should move, at a pace of 0.89%. And of course, this is a question to all of us as he was giving some of the talks in various presentations that he made. And thirdly, one of the challenges that is critical and it will also be reflected in the work that we're doing in terms of contribution that we're making is that in 2022, he mentioned, just over 225,000, postgraduates that have been, graduated. And only 29%, were in the science, technology, and the maths, engineering and maths, field, which also raises a question because agriculture is a science. And the question is, are we as academics and scientists, myself included, but in the main, he painted a picture about the overall, dwindling or declining innovation and commercialization in South Africa. And this is backed by the fact that we are exporting or rather we are importing more innovations than we are, innovating in the country. But fortunately enough, and also as one of the acknowledgements to the VC, the principal and the VC and her executive, is the marching orders on the 10 catalytic niche areas, which aims, among others, to drive research, innovation, commercialization, and of course, community engagement. And this is for all of us to ensure that in our various spaces that we play, this is at the center of what we're doing. If anything, these are marching orders, and ours is to align in our various spaces. And the work that we are doing will not only align with this, strategic direction of the university, but it is also with the SDGs, the United Nations Framework Convention on Climate Change, Continental Africa 2063, and NDP, and so on and so forth. This is so that we become relevant in what we're doing and not just doing research just for the sake of doing so to present in conferences and publish papers, but to ensure that the work that we do makes a difference in the communities, particularly with the people. The research that we are doing, it is people-centric. That is, people are at the center or at the heart of the work that we're doing. That is, anything and everything that we do, if it does not impact the people, then it is not ticking the right box. So of course there will be a need, for basic science that is required, of course, to understand some of the dynamics in the rangeland spaces. But last but not least is the fact that the work that we are embarking on, should address real life challenges: poverty, food insecurity, inequality, and you mentioned these are day-to-day challenges that people are faced with. Moving right along, it's the fact that as the institution, we have been asked more than once in different ways to say, whose research agenda are we addressing? And this question bothered me quite a lot, including even in the G20 side event that was hosted by Unisa. I can't remember when, but just before the main G20 event. And it is for that reason that I had a slide where I said we need to pause and basically reflect on where we are as a country. And this question was basically asked by some of the people who are not in academics, who are in the business space. And therefore, to me, among others, to respond to this question, so that we're not doing research for ourselves, because for many years we've been doing research for ourselves to tick boxes in terms of how many publications, how many students, but we are just scratching the surface. And that does not mean that what we're doing is not important, but we need to expand on the value process or the value chain of what we're doing. And therefore, in this program, we are not only going to develop capacity, but we're going to be strategic and intentional, that we produce postgraduates that are fit for purpose, that are Black, that are young, that are coming from disadvantaged areas. And we cannot dilly-dally on these issues, because these are the realities that we are faced with as a country in Africa. And therefore, it is important that, we address those issues. And it will also mean that we are starting to address real issues that affect people on the ground, rural communities in the main. But two is that there should be an emphasis, the research that we do through MSCs, PhDs, and of course honors who are very critical in the space, emphasize on innovation and commercialization of the research that we're doing. This is so that we can address some of the issues that I've mentioned. I found it prudent that, we paint a picture for those who may know in terms of what is the state of rangeland in South Africa, and what is its importance in food systems in the main. For those who do not know, is that rangeland, or what is commonly known in South Africa as a veld, covers about 50% of the global terrestrial surface and about 80% of South Africa's land surface. And this is a very important statement, because it talks about the importance of various ecosystem services that is provided, by rangeland. But in contrary, the United Nations Convention for Combating Desertification in 2024 shared with us that there is a silent rangeland demise, which is concerning, and it's not only at a global level. We can see even in our spaces in communal rangeland. For some of us who are coming from rural areas, you can see that the rangeland is degrading, particularly in the communal space, and therefore even worse is that about 50% of the rangeland in South Africa has degraded, and almost 100% is prone to desertification. All this has got negative implication for food security and the overall well-being of the citizens. And therefore, the work that we are doing is going to contribute to address some of these global, continental, and South African issues. The picture in the background is one of our study sites in Beto in the Eastern Cape. You can see that there's a gray, apologies, let me go back. there's a gray, encroaching shrub that has really taken over the vast, rangeland. And unfortunately, this comes with implications, including but not limited to the decline of grazing areas for livestock. And this is what UNCCD is talking about the silent rangeland demise. And we have also thought hard about the approach in the work that we do to say, as much as I'm a rangeland scientist or I am working with rangeland scientists, problems does not present themselves only as a rangeland science. And therefore, it is important to use a transdisciplinary and interdisciplinary approach, which is what we are doing in addressing the problem. And we also acknowledging that business as usual is not going to cut it. And therefore, there needs to be a paradigm shift in terms of, among others, how we approach research. And this is exactly what we are doing. And therefore, it is for that reason that we have got cross-cutting different skills and expertise within our consortium, within the bush encroachment chair that range from rangeland science to pastoral science, soil science, animal nutrition, GIS and remote sensing, social scientists, as well as data science, because there's tons and tons of data that has been collected, and therefore it is critical to have people who have got the know-how of managing big data, and it is therefore why we're having such people in this consortium. Here, I just want to paint, some of the work that we have started doing, and we are at the very beginning of really building this consortium, which, in my view, will grow to beyond a consortium and a chair for the bush encroachment in South Africa. And among others, we acknowledge and appreciate the seed funding that is provided by Unisa, and thanks to the executive dean and her committee, and of course the deputy dean, for affording us the seed funding. But what we then did in a short space of time was to look for other external funding, and fortunately, when knocking on various doors and writing different proposals, we will then be able to get 10 million, which will then be co-funding from both Unisa and the Department of Agriculture, as well as the ARC, to undertake a bush encroachment chair project, which is also part of the consortium work that we have started, that we are tapping into. But we have also, at this point, have 10 postdoctoral fellows, of which five of them are under my mentorship, and the other 5 are under Dr. Thamsanqa, who's also playing a very pivotal space or role in this consortium and bush encroachment chair. And to date, just for this academic year, we are in the process of finalizing 14 and 11 PhD candidates, but our target, for 3 years is to have 30 MSCs and PhDs, and of course, we will also have some honor students as and when they are, available. Very critical, one of the issues that has been mentioned in the meetings that I'm attending is the importance of partnership. And in this case, of course, there are quite a number of colleagues from within Unisa, or both within, in the various departments that we're collaborating with, but also there's a number of local and international universities. I couldn't mention them here, the list is long, but this include, among others, the University of Namibia, one of the Science Council as well in Botswana, National Agricultural Research Institute that we are working with, but we're also working with several institutions, including the University of Reading, which is where I am, some universities, North Dakota University in the US, and Lincoln, Nebraska, among others. But of course, the Agricultural Research Council, the Provincial Department of Agriculture, who are very central, and in the main, the National Department. So, and communities, as well as non-community who are not in farming, but they must benefit one way or another in what we are doing. And I want to paint, some of the work at a high level that we'll be doing, which will include, among others, exploring the effect of health condition on animal performance, reproduction, physiology, animal health, and ultimately the profitability, which is what matters to farmers. You can do anything and everything, but if it does not make business sense, we will still not completing the whole value chain. But we will also be exploring the rate and extent of bush encroachment, given its problem in nature in various systems, but to assess its ecological and socio-economic impacts, identify context-specific drivers and solutions, because we are aware that you cannot do work at our farm, Unisa, and apply it across, because this is a complex system. And that will also lead to various sustainable management interventions, including, among others, the restoration strategy and, of course, a policy. But in the main, this project will lead to, the establishment of, an incubation hub. This in the main to address some of the high unemployment issues in the country, but to also expand on innovation and commercialization. And one may ask, how are you going to do this? At this point, I do not have solution, but one of the solutions is that it's going to be done. And I have brought some of the business people who are not in agriculture, but they are business people who may be in life space and will make a contribution to this space. And again, this talks to the value of partnerships. I have got a problem of talking very lengthy, but I'm going to try and be quick. And so I'm not going to touch on everything. So some of the research themes that we're looking at in various spaces, including but not limited to rangeland science and planted pasture, which is where I am, is to explore, vegetation ecology and management, grazing management, fire ecology, rangeland degradation and restoration. And this is also one of the projects that I am collaborating with, or we are rather, collaborating with the Agricultural Research Council on this project. But not only that, but we will also look on climate smart planted pasture, which will be established at our farm, in the coming wet season. Very important, it's the work in the GIS and remote sensing, where we're going to look at, climate issues, drought, floods, extreme temperatures. We'll also do the mapping and modeling, including machine learning, because if we're painting a scenario to say, this is the current state, this is the status quo, so two things can happen. It is either we're going to leave things the way they are, this is where we will end, or we will try to make interventions in the form of this program, and this is where things could be. And farmers or communities should then see it for themselves, but not only see it without the actual impact in terms of the financial gains that they make in the space. Very important is the socio-economic, ecological systems. You remember in one of my slides that I've mentioned, it's people-centric. And therefore, we cannot do rangeland science without, socio-economic pressures, governance, and policy issues. These are realities on the ground. Without social equity and environmental justices. And of course, how are the communities, going to be resilient to these changes that, we are faced with? Most importantly, it's capacity building in the form that we're making. This is one of the most important slides, and Prof. Masindi, I've promised to engage you. I'm still coming. And this is because one approach that they're making in the work that we do is that it is high time that we do not only see problems as problems or challenges as challenges, but we need to see challenges as opportunities. And this is because in the rangeland, for instance, some of the encroaching species that I was showing you in the picture, and the one that I've showed in the Eastern Cape that has dominated the rangeland, it's called the blue bush or Tyronia incana. And the same is true with many other problem plants, has got a number of phytochemicals, including but not limited to terpenes, flavonoids, and you mentioned them, which are beneficial in many ways in the animal health spaces. But I had several engagement with Prof. Ntwasa, and once again, apologies, Prof, for not sharing some of the information, it's still coming, to say, I am also not only limiting ourselves to the rangeland and animal space, but it is important that some of the work that we do, we should collaborate with the pharmaceutical people who are working in that space. And Prof. Ntwasa is one, example of a leader who is pioneering that space to say, as much as there are these problems, but they could be beneficial in terms of these phytochemicals that are found in the various plants, but to also look at a possibility of, in the process of managing this encroaching woody species that affect, among others, in the grazing capacity, how then can we make animal feed in the process? And one of the areas that is often not looked at is that rangeland play a pivotal role in the textile industry. In the form of the very same phytochemicals which can be used as natural, dyeing. And therefore, this is not my space, but there is a need, for working with people. So this is the structure that we have at the moment. At the top, it's myself, Julius, but a core PI is Dr. Humphrey Tamaha from geography. Hence, I've mentioned him several times. And this is the importance of him in this space. It's how critical GIS and remote sensing is in rangeland science, given some of the methodologies that we use. But not only that, so there will be different themes that, among others, that I've talked to, and each one of them will be attached, with a postdoc, under which then we will have various honors, MSCs, and PhD students that will, address the various thematic areas. And so in the process, we're not just capacitating your MSCs and PhDs, but we're also capacitating the postdoctoral fellow such that at the end of this program, they've got a different way of looking at rangeland science, and not only as a rangeland science, but as a system in totality, among others, including some of the reasons that I've mentioned. But it doesn't end there. There's also another arm of ensuring that we are bringing other partners who may not necessarily be part of the structure, but they will come in as collaborators. I've mentioned Prof. Ntwasa, I've mentioned Prof. Masindi, and there's many other colleagues that we are working with, Prof. Malachi, Dr. Mushidi, Dr. Elsabi, who's going to look at the meat quality characterization as a result of this feed that will be created. And so there's quite a lot that will be happening. And what are some of the points? It's half cooked. So what we are then doing is to have, a book with several chapters that focuses on bush encroachment in Southern Africa, from all aspects, from rangeland ecology, GIS and remote sensing, socio-ecological systems, and you mentioned them. But it doesn't end there. We were also saying that what textbooks or what materials are used at universities, at primary, at high school in rangeland science. There is none. And so this is a space that we are entering in, including even, books that will be relevant for practitioners, policy makers, and you mentioned them. And so this is one of the areas that we feel, will make quite good strides. And in fact, in the discussion with the ARC, last week, they were very in support and are waiting for us to lead the pack. And of course, the obvious scientific papers, and you mentioned them, capacity building. But same as what Prof. Masindi has said, it is the patents. You will know that there's quite a lot of intellectual property that will come out of this work. And therefore, it is important to tap into that space and expand, given some of the pointers that our minister have mentioned. And I've highlighted the issue of incubation program. And we are also in the process of engaging Buan in Botswana, who have actually started on this program, so that we can learn from other neighboring countries in terms of how do they address some of the issues. And of course, policy briefs, which are very important for government space in this area. Very important is we are going or are in the process, although the progress, it is not as good as Prof. Mapoli would like, is that we are developing BScs, MScs, and PhD in rangeland science. And this is a very a good niche because none of the South African universities offers this degree. In the past, and even currently, University of KwaZulu-Natal, where I did my PhD, have got the grassland science, but not rangeland science. And in that space as well, things are also as they used to be 10, 20, 30 years back. And you go to the University of Fort Hare, you will find, such degrees in pasture and livestock. And so this is one of the areas that will not only, contribute to the program that we are running, but also in start to make strides in South Africa in the main. To date, we have not done much, but this is where we are in terms of research outputs. But at any given time, we're looking at doubling or tripling these numbers, which is very much possible with the plans that we have. And in fact, the work has actually started. So this is not just plans of what we're going to do. As I'm speaking, my team is in the field collecting data, and so we are planning to go out in the field as well during this dry season. And so is the coming wet season. These are some of what we have done, and I'm just going to jump straight to the conclusion to say 4 points that I made, I thought I should put clear here. One is the need for creating a conducive environment in this program for it to be successful. In my first slide, I've talked of the importance of people. And so this is one of the pillars. The interest is not on how many papers, how many book chapters, how many conferences. That for us, it is the product of ensuring a conducive environment. And that's the approach that we are taking. It has been done elsewhere under my leadership, and I'm very much confident that it will be done here. Second is evidence without collaborations and or strategic partnerships becomes just a shelf report, which has been happening in the main in the country. If you look at what universities have produced in terms of papers, in terms of thesis, but on the one hand, you look at the challenges that we are faced with, you wonder, what are we doing as scientists? And therefore, it is very, very important to have a different way of looking at collaborations, which will include, private sector. And as I've mentioned, we are people or community-centric research, not just research in isolation. And of course, we're looking at translating science to, address real issues. And of course, that will be usable to the end users. And I would like to thank Prof. Tagwe, Prof. Mabelebele, Prof. Ganta, Prof. Lebelo, the executive for the college in the main to appreciate what they've done, for us for now. And I'm hoping the same is true with anyone. But what is important is that we can't wait for them to approach us. It is us as academics, as scientists, who should really lead the pack, and the support it is there. I've seen it. But I would also like to say to them, an enabling or a conducive environment is a very good recipe for innovation and impact, and you mentioned them. This is really to my seniors, and I'm very happy given some of the issues that have been raised by Dr. Blading, and it is really up to us. Very important. It is the need, for resource support, being in HR and infrastructure, and you name them. And this is also because Dr. Mzimande also mentioned how thin researchers are spread. And this is problematic because some of the issues, may not be realized, not because we do not have the capacity, but because of some
in a way that all of us here will be able to understand, especially these applications. So for me to start, I would want to start with the quote that everything in nature has a very unique way of reflecting, absorbing, and emitting radiant energy. And for that, we can therefore be able to distinguish between a number of features because they tend to have different ways, especially of interacting, especially with the radiant energy. And that makes remote sensing a very important science, especially in a way that it will help us, especially to understand how different features are changing over time how different features are changing over space and so many other physiochemical changes that are happening, especially over the surface. Right? Briefly, remote sensing is the science. Some, they call it art of recording information without being in physical contact, especially with objects. There's a camera there, and it is recording, especially what we are doing here. So I can safely say this is one of the remote sensing applications, right? What we are doing here. So what is normally an issue here? There are a number of sensors that are plugged, especially in different platforms, and they tend to sense or record, especially information at different scales. I will explain about those scales so that at least all of us will be able to understand how important this remote sensing is. So here I decided to just paint a picture of optical, because there are so many types of remote sensing, but this one is an optical remote sensing, which means it relies especially on solar energy. So here, the sun will emit what you call electromagnetic radiation, and these rays will be interacting especially with a number of objects over the surface and also in the atmosphere. And what normally happens, so the sensors that are plugged in the space that are called sensors, they will tend to record especially the reflectance of this energy that is emitted, especially by different objects. And in that way, we'll then be able to understand how different objects are changing or how different objects are, especially over the space and time. Right? And there are a number of obstacles, especially that limit the usability, especially of this technology, such as the cloud cover. If there's a high presence of clouds, it means these sensors will not be able to record especially energy precisely because the cloud will limit, especially, or will obstruct, especially the recording, especially of this energy. So when there's a high presence of clouds, then we tend to have some limitations, especially in some of the sensors. But there are sensors that are able to overcome this limitation where they will be able to sense regardless, especially of the presence of clouds. And these are some of the platforms that are important. Here we have a space-borne remote sensing, which involves the sensors or the satellites, especially over the space. So it means like kilometers and kilometers away, there are sensors that are orbiting or that are rotating over Earth, and they are taking different pictures or different images, especially over the surface, and we refer to them as space-borne remote sensors or satellite sensors. We also have airborne sensors, such as drones and aircrafts, where they will fly at a low altitude, and then they will be able to record, especially these dynamics as well. And also we have a last one, which is called the terrestrial remote sensing, where I will have a handheld scanner, for instance, and then I can scan rocks, I can scan different materials or objects, and then I will be able to see how different features are, especially in terms of their different physical, chemical dynamics. And the fundamentals, remote sensing, especially optical remote sensing, we base our analysis, especially on the analysis of what we call electromagnetic radiation. Here, these are different sets of bands that are channeled or that are clustered, especially in different regions or in different channels. So for instance, we have a number of channels such as X-ray, where our naked eyes, unfortunately, will not be able to make. Other colors are a combination, especially of these colors, right? For instance, if you see a white object here, it will be a reflection, especially of all these colors in equal proportion, and then you see an object as white. If you see a black object, it will be all these colors are absorbed, especially in equal proportion, and then you will see that kind of an object as what? As black. If you see a green object, blue and red are absorbed, and green is reflected, and then you'll see that object as what? As green. If you see a red object, red will be reflected, and then you'll see green and blue will be absorbed, especially in that particular object. So objects are different in nature, and they are different, especially in the way they interact, especially with light. And that's why we have different colors, especially that because of time, I will have to rush. And then these are 4 important resolutions that explains or that makes our remote sensing very interesting. For instance, we have what you call a spatial resolution. If you talk about spatial resolution, we talk about the smallest unit that the sensor can be able to sense. So for instance, if there's a sensor and then I want to identify the number of buildings, especially in this particular campus, if the sensor is 1 kilometer, for instance, I will not be able to identify even a single object, especially or a building in this campus. But if I have a sensor that is 0.5 meters in terms of resolution, I will be able to identify all the buildings here because there's no building that is less than 0.5 in terms of the resolution. So spatial resolution is important in that way. We have a spectral resolution, which tends to involve a number of colors that are that can be distinguished, especially from features. And then we have a temporal resolution. There we look at how frequent, especially is the sensor is able to capture one area, especially over time. And then we have radiometric resolution where, for instance, everything is based especially on light. So if the sensor was unable to record, especially the light intensity, you may find that maybe you want to identify buildings, and then you find that buildings are almost similar in terms of reflectance, especially with the images that are free of charge. So if you have an account there, you can just set up your account, and then you can access a number of images for free of charge. And then there are functions as well, and there are a number of data sets that are ingested in the system. It means you can be able to analyze this, and this is a cloud-based platform, meaning I don't have to have a physical computer like this so that I can have maybe images, I store the images and stuff, and the storage implications are not an issue here, because whatever I do here, it will be saved in the cloud, and then I will only have an output, and then I will be able to analyze. And then what is nice about Google Earth Engine is that you can be able to take create a code where it can analyze something. You can send it to your friend or colleagues, and those colleagues will be able to have a similar that code, and then they can see maybe where there are issues, or maybe there are problems, or maybe they can add maybe some advances. So it's an interface that requires especially some basic programming skills. So it is important in that it will allow us especially to analyze different features without needing especially a physical computer, because in some universities there are very serious challenges, especially of accessing softwares, because some of the softwares are very expensive, especially to have. So this one, it levels the ground for all researchers, especially to have access, especially to images, and to have an ability, especially to analyze all the problems and features, especially through this kind of a platform. And let me start my applications with agriculture. We know agriculture, and I will use forestry as an example. For instance, we have what you call inventory. So you need to know how or when the species are harvested, for instance, what type of species are there in terms of the compartments and all of that. So that is important. You need to know the performance, especially of different species over time, because some of them will be affected by drought. If there's a drought, some of these species will not perform well, and they will tend to be affected. So you need to analyze this time and again so that you can see the performance of these species, because what is important is to optimize and is to have a very positive yield, especially at the end of the day. When you harvest these species, you will have a very important yield, especially in terms of the stock. So if you don't do that, you are likely to have species that will be affected by a drought, for instance, and then when you harvest, you will have lesser stock because of what? Because those species maybe were subjected, especially to harsher conditions that limited them, especially in terms of their growth. Also, the operations. For instance, if you want to harvest, you need to know the surface. For instance, the surface roughness. You can't just go and deploy a machine that you know where you don't know. Maybe there are rocks there, or maybe the surface is maybe different. So you need to know to understand the surface so that you know the type of machine that you can deploy, especially to harvest. So the operations. So remote sensing allows us especially to have all those things, especially in order, so that at least you can optimize the productivity and also the profit or revenue, especially at the end of the day. Right, my first example here will be, in agriculture, will be the pest infestation and disease outbreak. With remote sensing, we can correctly, or we can accurately identify areas that are facing these kinds of problems. For instance, if you have a commercial forest, and this commercial forest is infested by pests, what you can do is to take an image there, and then you can look at the different phases, especially of that particular forest, and you can be able to identify areas or trees that are suffering, especially with these, from these pests and diseases. For instance, we have different bands that I explained in the electromagnetic spectrum that are important. For instance, if you want to understand how severe, especially is this outbreak, you will have to profile what you call a temporal signature profile, so that you can see the images so that you can see the profiles. And then those profiles will give you an indication of how stressed are those trees. Because if they are infested by pests, they tend to be stressed, they lose water, they lose moisture content, and then they tend to be drier. And in that case, you can be able to profile a spectral signature. And then the spectral signature will give you an indication of how severe, especially, is that particular problem. For instance, if you check 1.4 micrometers to 2.0 micrometers there, those are, that is a shortwave infrared region. And the shortwave infrared region is very sensitive to water. So anything that will have water or moisture content, you will have to use those bands because they are very sensitive to water. In this case, for instance, those trees, the upper one is greener, so you'll see if you check the spectral signature for that particular tree, it is 142 in terms of moisture content, the percentage of moisture content, but the lower ones are more infested and they don't have much water. So if you see the water content is much lower there, it's 0.0, so it is represented by that orange signal there. So if you look at the shortwave infrared, from 1.4 to 2.0. 1.4 and 1.9 are very important strategic bands where you see more absorption happening at 1.4 and 1.9. You will know that the plant is healthier or the plant has more, or has like moisture, especially in it. But if the plant does not absorb, especially at 1.4 and 1.9 regions, it means that plant doesn't have much water because there's not much absorption happening, especially at 1.4 micrometers and 1.9 micrometers. In that way, I can safely say that plant has a problem, especially of moisture content. If you go to the field, you will see the plant maybe is losing leaves or the plant is becoming drier and drier because of what I've seen here. So I can have an image and I can analyze my image in office and then I can safely explain what is happening, especially in the field, based on what is given, especially by this kind of profile. Right? Soil organic matter, we can map soil organic matter. These are some of the projects that I've done, especially with my students and some collaborators. For instance, soil organic matter, we can go to the field and measure soil organic matter, and then using some spectral, because there are a number of bands. For instance, I have not explained that in remote sensing, we have what we call hyperspectral remote sensing and multispectral. Hyperspectral, they have a number or thousands and thousands of bands that are sensitive, especially to different elements. So if you analyze them, you will now be able to recognize or identify a band that is sensitive, especially to soil organic matter, and then you'll be able to, it will explain, especially in terms of the curve, how that particular soil moisture is a problem, especially in that particular area. So in that way, you can then be able to distinguish between areas that are suffering from soil moisture, soil organic matter, from those that are not suffering. For instance, in this case, it was some area near Beckville. You can see soil moisture around areas that are greenish there, those are greenish sampling points. They are more into agriculture, so there are a lot of agricultural farms that are there. And you can see there's a lot of, there's a higher concentration, especially of soil organic matter there compared to other areas, especially that are irrigated and, that are degraded and stuff. So these are some of the things that can happen. Also, in terms of weeds, we know for those that are more into agriculture, weeds are some of the very important problems, especially that can limit, especially the growth of different crops. So the question is, how can we identify, or how can we best identify weeds, especially so that we can optimize the growth, especially of different crops? Here, we can use also high-resolution images so that we can be able to do what we call anomaly detection. Or if the crops are growing healthier, then you will have like normal conditions. But the moment you bring in weeds, then the image, you tend to see now the anomalies. And those anomalies will change the spectral signature and they will change the organization, especially of the profile there. And then you will then be able to see in those anomalies, you'll then be able to identify that, okay, in these areas that I see as anomalies, there are weeds that are present there. If you go physically in the field, you can then be able to identify especially those weeds. So this is one way that is easier, where you can be able to map and understand especially those weeds. For instance, the second one is fires. We can use fires, we can map fires, especially in different areas, in grasslands, in rangelands, like Prof. Gerwell was indicating. For instance, we can use the bands, because if you ban vegetation, it tends to lose water, and by losing water, so it means we can use the shortwave infrared. And by so doing, we can understand areas that are suffering from fire because I can take a before and after image, and then before fire and after fire, and then I can be able to see all areas that will have scars, especially that were affected by fire. And this is one of the practical examples that we used. I can also map, in terms of forestry, I can map also because in forestry, when you see those trees, their harvest is as a result of what you call the width and also the height. So I can, if they are at a certain height, say for instance 15 meters, it means I can be able to apply maybe LiDAR, and LiDAR will send some protons there that will interact especially with the apex and also in the ground. And by so doing, I can subtract the height and also the lowest part, and then I can be able to estimate the potential height, especially of different trees. Prof. Masindi was explaining about water quality here. So you can go to different streams and measure, for instance, turbidity, you can measure pH, you can measure water conductivity and stuff like that, electrical conductivity and stuff like that. And you can do what we call interpolation, and also you can use remote sensing because there are sensors or there are bands that are sensitive, especially to different water quality parameters. And then you can be able to have a nice profile, especially of where these problems are, especially in this particular river system. Lakes are suffering, especially as a result of climate change. For instance, we have seen in Maputo land, especially on the way to Mozambique there's a serious lake, there's a serious problem that is suffering, that is affecting this particular lake, where there are a large number of planted forests, commercial forests that are planted, especially around this particular lake. And this lake is suffering now because the water is shrinking. And why water is shrinking? It is because those trees are referred to as stream flow reduction activities. So the moment you plant them, they suck up more water from the ground and they limit, especially groundwater. And as a result, all the systems that are there, surface water resources, will tend to shrink as a result. So we have mapped this, and when we've seen how important or how those trees are implicating, especially the entire system. And I have some students that are currently undertaking some work there because we want to understand the intensity, especially of those forests, especially in how they are implicating, especially the entire area. The time is not on my side. Let me just summarize. Applications on drought. Also, you can use, there are many drought indices that are based on chlorophyll, for instance, that are based on moisture content and many other parameters, where we can understand a number of features that are affecting vegetation in different ways. In that way, we can be able to see areas that are suffering from drought and stuff. And also we can graph this along with the rainfall and temperatures, and then you can see how vegetation is responding, especially to variation, especially temperature and water, for instance, over time. And also we can map air pollution. There is a sensor that is called a troponin instrument, Sentinel P5, which is a troponin instrument. It is sensitive to a number of pollutants in the atmosphere. And in this case, we can map a number of air pollutants. For instance, here, I was working with my master's student, and here, these are profiles, especially of NO2, especially across South Africa. And what you can see here, there you have December, January, February, and then you can see the concentration there. Why it is so small, why it is so like a little there, it is because in December, Jan, Feb, we have higher rainfalls, and as a result, they tend to wash down, especially these pollutants. But in June, JJA there, you see there's a large concentration of these pollutants. And if you see rainfall there, you see rainfall anomaly. In South Africa, in this part of South Africa, then we don't have much rainfall. And as a result, there will be a large pollutants that will be suspended into the atmosphere. And then there will be large concentrations there because there's not much mechanism that will bring down the concentrations of these. So we don't have much rainfall here, but in regions or in seasons where we have rainfall, you will tend to have less concentrations, especially of these pollutants in the atmosphere. So we can do this using remote sensing. Also, we can have EMSAT, where we can see where we can see especially the propagation of different weather systems. For instance, if there's a cold front propagating towards Western Cape, we can see and track this development and see whether it will hit maybe Joburg or maybe it will hit some coastal provinces and stuff like that. So this is one of the remote sensing applications here. It was a study in Cape Town where we wanted to analyze coastal erosion because there are very serious erosion problems, especially across South Africa. And here we found out, especially in those areas that are reddish, there's a high prevalence, especially of erosion there. You see, in some cases, you will find that the coastal line is stretching maybe to about 100 meters, especially inland. And that presents a serious problem because there are a lot of coastal infrastructure, especially that will be affected, especially by such a pattern. And also we have mapped especially the heavy metals in Richards Bay, especially along the coast, because this coastal erosion can be attributed to a number of factors. So by understanding the physical, chemical compositions, especially of these metals, we can now understand especially how they are affecting especially our coastal systems. Here, it was flood mapping. We can also understand and map floods. Recently, Limpopo was flooded, and we can clearly identify areas that are flood affected or that are prone especially to flooding by understanding or by taking an image before and after the flooding event, and we apply these shortwave infrared bands, and then we can therefore be able to identify all areas or all pixels that are flooded, especially in that particular area, so that you can identify even the people that will be exposed, especially to those flooding issues, so that at least they can be relocated, especially to safer areas. So these are some of the things that we have done with my students using remote sensing here. Land use, land cover change in Maseru, we've mapped so that you can see how different land use and land cover classes are changing. For instance, here we're targeting especially built-up areas as a function of urbanization, and we can see the propagation and the growth of urbanization over time. And here, why urbanization is such an important concern. It is a concern because there are a lot of people that are moving to urban areas, and if there's no maybe vegetated kind of structures, you can have what you call thermal stress that can affect a number of people there. So we can also identify thermal stress, especially in different cities and towns, because there are sensors that are very sensitive to thermal bands, and thermal bands will allow us to map the temperatures, especially in those cities, and then you can see how people are exposed to different areas that will have thermal stress, and if they are exposed to those, then it can mean, if for instance in South Africa we have a challenge of water resources or access to water, so if you don't have access to water under very high temperatures and maybe heat waves, those people are likely to be affected, especially in different ways. For instance, we have done a study in Durban where we're looking at women that are pregnant, and we're looking at how they are affected, especially by heat stress. And these remote sensing applications allows us especially to identify areas that will have more severe stress, thermal stress conditions, so that at least we can be able to have more supply of water in such areas, so that at least we can safeguard those communities or people. 1 minute. I'm a geographer, just a second. Okay, 1 minute, I promise 1 minute. Yeah, nighttime light. So also at night, when you switch on like lights at night, there are sensors that are also recording those intensities, so that you can see areas that have higher light intensity from those that are, so all areas that are developing. You can even track developments. You can track economic growth, because there's no way an area can grow economically and then without having some lights. So those areas that will have more intensity of lights will be assumed especially to be areas that are growing, especially in terms of their economically, and then you can be able to track especially those issues or those indicators, especially using remote sensing. Also the species distribution. There are species native and there are species that are alien in South Africa, and we can be able to track all those species that are not, native, and then we can see where they prefer to grow, and then we can even project that, okay, in near 2050 or maybe 2060, how those species will survive, especially in such areas, because some of them are sensitive, especially to temperature and rainfall and many other parameters. So we can use the bioclims there, and then we can be able to see how the spread, especially of different species are, especially in South Africa, and then we can make even predictions using machine learning, deep learning, and many other innovative kind of analysis systems. Here, this was a road accidents that were recorded in Durban, and here we wanted to identify hotspots, especially of areas that are where there are more prevalence, especially of road accidents. We can also do the same thing as a crime. I recently got data, especially of crime incidents in Durban. I'm hoping to approach Prof. Smith so that at least we can make some patterns, especially so that we can see areas that are affected by different levels or different types of crimes, especially across that particular area. So we can certainly do that, especially using remote sensing GIS. So with these kinds of examples, good people or colleagues, I was trying to demonstrate the applications of remote sensing and how important they are in allowing us especially to do some different levels, especially of analysis that can allow us to collaborate with different colleagues from different schools or different departments. With these colleagues, I thank you so much. I'm so sorry about extending time. Thank you, sir. Thank you so much.
Thank you so much, Prof. Pulu, for that passionate presentation. Thank you very much. Colleagues, I know we're tired. I know we're hungry. We have our last presenter for our second session. It is our Prof. Ntwasa. Prof. Ntwasa is a biochemist and a translational scientist whose career bridges in molecular biology, cancer research, and higher education leadership. He earned his bachelor's degrees in microbiology and clinical science and immunology from the University of Cape Town, followed by his master's and PhD at the University of Cambridge. Returning to South Africa, he served as the research fellow at UCT and spent 17 years at the University of Witwatersrand, rising to associate professor before joining us at Unisa. As a professor of biotechnology and acting executive dean of the College of Agriculture and Environmental Sciences. His research has included topics such as apoptosis, autophagy, innate immunity, and cancer biology, with pioneering work in retinoblastoma binding protein 6, a regulator for P53, and a promising therapeutic target. He has published widely, secured international patents, and advancing drug discovery through small molecule inhibitors of cancer pathways. Beyond science, he's a leading advocate for transformation in higher education, emphasizing inclusive, socially responsive research and entrepreneurship. His contributions spanning to scholarship, innovation, and leadership to continue shape cancer biology and inspire the next generation of African scientists. Prof, I hope I did you proud there.
Sure. Good morning, colleagues. Oh, good afternoon. First, I'd like to thank Prof. Mabelebele. Is she here? Prof. Mabelebele and her team for organizing this important platform and also for inviting me. Colleagues, I want to report that Prof. Mabelebele called me one morning early, did not even greet me, and said, you are going to speak on the 27th of May at the R&I meeting. I want to report this because I want you to know how I'm treated. Don't look at me and think I'm happy. I'm not treated very well. That's one of the people that do not treat me very well. I'm happy to speak after you, Bishop, because I think that the area of geospatial sciences is very important. And I think it's underutilized actually in South Africa, especially remote sensing. So thank you very much for that. What must I do now, Spoon? Oh.
I didn't want you to see me on the screen, that's why so, colleagues, mine is very easy, and because I would finally like to thank the team for making me speak last, and when I'm hungry and exhausted, because I don't want to annoy you, I won't speak for very long. I'm going to speak very fast. I'll probably skip some of the slides. So mine is very easy because I want to introduce to you the Center of Excellence in Drug Discovery and Development, which is proposed by the Department of Life and Consumer Science. And what I'm going to talk about is a synthesis or a summary of a meeting, a consultative meeting that we had last year, the founding members of the Center of Drug Discovery and Development. And the aim, really, what I hope to achieve by this presentation is to attract more people into this center, because although there were quite a number of us at the consultative meeting last year, I know that there's still a lot of people who are interested in veterinary solutions and clinical solutions in the college who were not present there. So I hope that you will take and you will understand more about what the center is about, and also join us. So the purpose of the center really is to create a pharmaceutical platform and also harness an appropriate ecosystem, both in the academia industry as well, and to drive a novel therapeutics to market. So the objectives of the center are listed there. First of all, it is about establishing a world-class research facility for drug discovery and development. So the Center of Excellence basically is a place where business is not business as usual. We're doing things at a higher level than we are doing now. We want to foster collaboration between academics, the pharmaceutical companies, and healthcare providers. We also want to develop reagents, diagnostics, and therapeutics to at least technology level 4. This is at the level where it's just getting out of proof of concept into developing prototypes. That's what we expect to develop in the technology in the Center of Excellence. We also are aware of the importance of artificial intelligence now, and we are already poised and have tried to recruit as many people as we can in computational biology in order to integrate artificial intelligence into our translational activities. And of course, funding is going to be very important. We hope that the Center of Excellence, although it will start with probably seed funding from the university, but from second year onwards, it should start driving its own activities. And of course, the main thing would be to drive commercialization. It is at the forefront of what we want to do. Just to justify why we think that it's important to have a Center of Excellence, if we look at the trends today in the area of drug discovery, machine learning is very important because screening of drugs has been taking a long time, but machine learning is making it much easier now and faster. So these are the trends. The other trend that's important now in drug discovery is personalized medicine, exploitation of genetic profiles to develop new clinical and veterinary solutions. The growth in biopharmaceuticals these days is moving towards biologics cell therapy, and also gene therapy. In fact, I saw yesterday there was a publication of a new, I think it's the first drug that's developed using CRISPR gene editing. It was published yesterday. So things are moving in that direction now. We are still in the area of medicinal chemistry. We're producing small molecule drugs. But really, the new trend is biologics, cell therapy, and genetic editing. The development of drugs is becoming more and more expensive. Now, apparently, it takes up to 2.5 billion from identification of a drug to the phase 3 clinical trials. It's not even at the level of manufacturing, but it's already taking that much. So these are the current trends that the center will have to deal with. Our target markets that we will be focusing on in terms of our activities would have to be pharmaceutical companies, obviously, those that seek new drug candidates, biotechnology startups, academic institutions and labs. See, some institutions might want what call assistance or use of our platforms. That's what we mean by academic institutions. Our platforms that will be in the center for their own activities, and we can offer those as services. We also have to have a dedicated what call facilities to deal with regulatory matters, because in the area of developing drugs, regulation is very important. I think my colleague from what's called, Thamsanqa, I think she talked about the navigation of this regulatory. It's quite sometimes difficult for us, and it can be a tricky area to deal with. But so we would need in the center to have what called dedicated agency to deal with the regulatory landscape. And also, we'll have to have dedicated facilities to deal with investors and venture capital, since our interests are to commercialize. We are aware in the center that our competitors are international, mostly global competitors. We don't have national competitors as such. In fact, it's interesting that where the drug discovery platform that we'll put in place will be the first one in Gauteng, and Gauteng is the most important province in the country, and yet it does not have a fully fledged technology, drug discovery technology platform. It's in other major provinces. So when we set up a platform, we'll probably be the first one to do a dedicated, fully fledged one. Of course, we know that there is a platform for drug discovery deliveries, what you call at VETS and at Unisa, but those are very focused platforms. So our competitors, as you can see there, are mostly global and very large. So they're not really competitors in that space, but they are probably also people who would benefit from our activities. Center of Excellence will therefore differentiate it by integrating artificial intelligence and also in screening drugs. So our interactions with these global interactors might be at the level of selling rather than actually competing at the level of the market with them. Our strategy would be to develop a state-of-the-art laboratories with facilities that are AI-driven. We would like to develop partnerships with academia and industry, and also would like to implement robust intellectual property management. Obviously, we shall work with the DITTC to do this. It means that it must be a normal practice within the center to test everything that we do, every project that we do against on a business canvas which you can do that, Sia, isn't it? Yeah. So we will have to test everything that we do on a business canvas, which we've already done such an exercise with DITTC, and I would actually encourage other colleagues to test every project that you do. Its translational ability, its translational potential. So we have 9 research themes at the moment, ranging from anti-cancer drug discovery and development, which is our group. Drug delivery innovations will also involve them. And I think we're going to have a very interesting, I did not know that CSIR was doing the sort of things that they told us they were doing in terms of drug delivery systems. We are interested in that area, and our focus would be on nanotechnology, but that is combined with photodynamics and sonodynamics. So I think we will talk with CSIR very soon. We also have host pathogen interactions. Professor Mkhize is one of those people, but there are other people also who deal with host pathogen interactions. Novel diagnostics in the area of veterinary and clinical solutions. Prof. Musebi is people that we hope will assist us there, and also with antiviral drugs. Cardiovascular diseases, psychedelics, Sana, Prof. Gadimeng is a star there, and antidiabetics, and also biocatalysis, industrial biocatalysis. These are research themes based on people who were present at the consultative meeting that we had last year. So centers of excellence must be focused. You cannot have everything and anything in drug discovery. So we have to look at the things where we have got human capacity. So I think that 9 research themes are already at a world-class level. Most centers of excellence in the world would benchmarked would have research themes ranging from 5 to 10. So 9, I think, is a good one. So the first thing, our technology plan that we want to have there is one of those things that I've mentioned there. Some of them are already around. We probably steal them from Eureka into a new building. Hopefully, I know that my people here are talking at Mancom in my absence to facilitate a drug discovery platform. So we need to revive the fly lab. The flies were killed when we were forced to stay away from the campus during COVID. We're still very angry about the lockdowns as a result of that. I curse them. We need an automated plant extraction platform, which I think would be actually a national resource that would service people even outside academia. I think very important liquid handling, sophisticated liquid handling, because high throughput activities would require automation, which excludes a lot of human work, because human beings on Monday, they're not very good. But we have equipment, must work at night as well. So we'd like automated stuff. Bioreactors. We're thinking the area of, because there's a lot of structural biology that's going to be involved here, X-ray crystallography is a bit expensive and too tedious also. We're looking at cryo-electron microscopy, which is less, but actually quite useful and quicker. We don't have expertise there, but we've talked to people at Cambridge University who are experts in this, and we can collaborate with them. We don't have full complement of people who will be involved in the Center of Excellence yet. Remember, it's also a proposed Center of Excellence. We have not even received proper formal word that it's been approved. We just hear say that it's been approved. But this is where we are. We are set. We are on our marks in the center. We're just waiting for Prof. Mambelebele to fire the gun, and then we start sprinting. So these are so far the people who were present at what called this is also not exhaustive, it's only those who entered their names here. So you can see that already we're talking about 20 master's students and 12 and there are only 3 groups. So the other 4 groups have not entered their people. So the center could start on a very good already the people who are leading the groups are already at professorial level. So that means that the succession plan of the center would also be quite secure. So I'm going to pause there to say thank you. If the chair will allow me, I will just show you a few more slides and then stop. But if you, see, Unisa says, so it's not me. If you're angry about lunches, just a quick things that I wanted to talk, because I'm just mentioning this because you might be curious to know. So these are things that once the gun fires, these are the things that we're going to do. We are on our marks now, but we have to start building an organizational structure, such as that, an executive leadership, scientific board, research teams, and business development. Those are the things that we will do as soon as we're on. And that's how our business model should look like, licensing and patents, collaborations, of course, especially partnerships with pharmaceutical companies. I think it's going to be important for us to have intimate relationships with pharmaceutical companies, especially those that we wish could co-develop with us. Service contracts, products, short learning programs, all those sort of things, part of the revenue streams that we are looking at. We are aware of the challenges. The high initial investment in this is a challenge. The regulatory bottlenecks are going to be a problem for us. And competition, of course. But as I said, the competition also offers opportunities that I think will help us. This is structure. The Center of Excellence will be based in the Department of Life and Consumer Sciences, and will be led by a champion who we have not yet identified. And the rest of it, everything that are below the green marks are basically the kinds of divisions and the human capacity that will be at the Center of Excellence, so that you have a picture of what the center would look like. Yeah, sekunjalo. Do you have questions?
Oh my, Prof. Thank you so much, Prof. Ntwasa. Colleagues, may we just call upon our speakers that presented in the second session. We just want to give you a token of appreciation. Thank you so much, colleagues, for your time and your attention for the second session. We are officially done and we're going to break for lunch. We've reduced the lunch time to 40 minutes, so if we can make it back here by 2:15, would be highly appreciated. This is our official logout from Pabalelo and myself. We hope that you enjoyed the third session and the well-deserved lunch break. Thank you, colleagues, again.
Emmanuel's here. Perfect. You can sit down, Emmanuel. I was just checking if the people that we're here for have arrived. So good afternoon, ladies and gentlemen, and welcome to the third and final session for the day. It's been a good day filled with robust conversations and innovative conversation on innovation on biotechnology, marine studies, health, energy, and digital advancement. My name is Matsuho Njubutla, and I am Marketing and Communication Specialist from the DITTC, the Directorate for Innovation, Technology Transfer, and Commercialization. My colleague earlier on did go a bit into what we do at the DITTC, so I won't go into that. It's an absolute pleasure for me to stand here and welcome you today on behalf of CAES's Research and Innovation Day. Can we, a round of applause, please? It's been a good day. It's been a good day. So today, I'm not running solo. I have a partner in crime who's going to help me navigate this afternoon session. But before I call him up, I do want to take this opportunity and thank our partners. You might have seen them outside in their stalls. Labotech, Whiteside, Separations, Advanced Laboratory Solutions, Anatech Analytic Technology, Sartorius, Merck, Z's, Thermo Fisher Scientific, and Ingaba Biotech. A round of applause for our partners. And speaking of Ingaba Biotech, I would like to call my partner who is from there. His name is Bule Shabalala, who is Area Sales Manager for Johannesburg, KZN, Mpumalanga, and Limpopo. He's going to be assisting me in making sure that this program runs seamlessly today. Round of applause for Bule.
Good afternoon, everyone, again. So emceeing or directing a program is not my strongest suit. So I was advised by a colleague to open with a joke. So I have a scientific joke, but I wrote it with a pen in my hand and it has since faded away. So maybe I will try it again next time we have this session. Only if you all promise to be here again next year, I'll promise to have the joke again written and I will make sure it does not fade away. So as mentioned, my name is Pule Shabalala and mine is very simple. My colleague has mentioned that I'm a partner, I'm going to be her partner in crime. Fortunately, nothing that will lead us to the Madlanga Commission. But yeah, it's just going to be scientific crime that is acceptable to be published. So again, maybe just to run quickly, I stand here wearing two hats. Right now, I'm standing here as Pule, the MC. Earlier, I've had some great engagement with some colleagues and researchers on the solution that Ingaba has, which we have engaged about outside. I just would like to introduce some names that are also important to the session, and these are the names of the judges. So to all that are in attendance, please know, whatever the results are, it's because of the people I'm going to mention right now. So we've got Carrie Ann van Galen from Separations. Round of applause for Carrie Ann. We have Dr. Siya Ntutela from DITTC. And we have Prof. Mutumun Managa. So Prof is still on the way, Prof is still on the way, and again, they will be part of the judging panel for today's session. I just want to maybe lay out the house rules for all our researchers that are going to be standing in front of us today. We have extended your time from 3 minutes to 5 minutes. So you have exactly 5 minutes. So myself and my colleague will be here close by. So when one of us stands up, it will mean that your 5 minutes is coming close to an exhausted. So again, as the good researchers you are, I know you have, and if there's any researcher that is maybe not good in keeping time, we will assist you in that. We have timers with us. So if you lose track of time, maybe one of us standing up will be an indication that your time is coming to an end. So you have exactly 5 minutes. Without wasting any further time, I would like to call upon our first presenter, Emmanuel Njoka.
Good afternoon, colleagues and everyone. I'm standing on the already established protocol. Permit me to rest on because this is very time limited. We are asking a big question whether human exposure to toxic heavy metals in African catfish is a fact or a fiction. Why are we interested? Because we've got some problems. We will be asking ourselves, are these fishes that we always fish and then eat, whether they are in the can, in the shelf, or whether they're in your freezer, are they actually the one fishing us? We are going to find out. Are there invisible contaminants in there that could pose hidden health risk? We are also going to find out. The last question we may not profile, we'll leave you to judge. We may not profile solution, and that is whether we are prioritizing the food security at the expense of the safety. Why is this study very important? What does it matter? Number one, we know that lead, one of the heavy metals, have a lot of brain problem. It can cause it, particularly in children. In some countries, in Nigeria, in some other countries, there have been problems with this, particularly in the young ones. Cadmium is associated with kidney problem. You know, arsenic is the chief of them, very carcinogenic. Doesn't matter whether you're a child or an adult. And then children are most vulnerable. And we also know that these metals, they are one peculiarity. Little exposure, even though it's small, they can accumulate over time and cause big problem. We've just tried to a kind of infographic, trying to demonstrate what these metals can cause, ranging from the damage to the DNA, sometimes irreparable, to decreased DNA damage, to what we call the reactive oxygen species formation, you know, or even altered cell cycle that can ultimately lead to cancer, whereby your cells keep dividing uncontrollably. They just got mad. We like it that way. So this can lead to a lot of health problems, osteoporosis, heart disease, and what have you. There are a lot of them. But what is innovative about this study is that unlike other ones, we did not just go to look at the fish tissues. We did an integrated food safety risk model, whereby we looked at the tissues, how much of these metals are there. We also looked at the pond water that where these fishes are grown. We checked also the feed and what have you. And at the end of the day, we found out that, look, the entire value chain approach is being considered. Because of time, these are all the SDGs that our study cut across. Key finding is that this arsenic exceeded the limit in 25% of the samples we took, the cadmium in 16.5%. Interestingly, all the fish tissues, they were all below permissible limits. In other words, they appear safe. But should we be celebrated? Should we start celebrating it? We'll find out soon. When we did the health analysis, we found out the hazard index, that is the non-carcinogenic effect, is more in children, even though for all age groups, they are below the limits. Then we also did what we call the carcinogenic risk, total carcinogenic risk. And then we find out that, again, children are most at risk, even though the range is fine. What are the impact of this study? One, we know that with this, we'll be able to have a safer aquaculture and improve public health. If we abide by some of the things we're going to say at the end, we'll be able to have a better policy and farm monitoring system, strong food safety across Africa also. We are definitely going to be supported because we need funds to be able to carry this along. This work was tested in Nigeria, but we want to do a Pan-African study where at least 1 or 2 countries, all the regions in Africa will be done. We are looking for strategic partnership with industries and corporate bodies because this work takes a lot of time, and we are looking to develop something that we can apply on farm without going to the lab. That is in the fields. What are the control measures? Can we really control this toxic metal by cooking it? No, we cannot. But there are other ways to put it down. Quality, water quality management, food regulation, and what have you. In conclusion, we can say that heavy metals were detected in both water, feed, as well as these fish. And then children show the highest exposure despite being within the limits. And then routine monitoring of this water and all these matrices is important so that there will be safety. The very last thing we want to say, that safe aquaculture actually begins before harvest. Many people think it's after harvest. You could be keeping it in the fridge, but once it's already contaminated in the farm, there's a problem. We need scientific evidence like this to be able to act in protection of public health. And luckily, we have just provided it. Thank you very much for listening.
Thank you very much, Manuel. That was perfect. We will be handing over to the judges for 2 or 3 questions.
Okay.
Thank you. My question is, what interventions would you recommend to put in place to help prevent these toxic metals from entering the human health and especially in children?
Thank you very much for finding some merits. There are a lot of them. If not for time, we would have elaborated on them. In my slide 12, I did mention that these are listed 4 major mitigation measures. Water quality management. If the pond water or the pond water is very well taken care of, these metals are not going to get into the fish. Same thing with the feed that these animals are fed with. All right, so regulating the feed industry, fish feed industry, animal feed industry generally is very important because some farmers or some producers deliberately put these things there because they enhance growth, something like arsenic. They enhance growth. But they don't look at the adverse health effects. Again, we talk about environmental management and industrial pollution control. Permit me to say that some industry, because of cheap method of disposal of waste, they channel their waste into the water bodies and some other, illegal means of disposing this. If we get rid of these things, the truth is that there will be these fishes will not be exposed. In a summary, it is anthropogenic activity that exposes on Earth this metal, and then they get into the food system. Once we take care of that, we'll be fine. Yeah.
You mentioned a Pan-African approach to the problem that you identified.
Exactly.
How are you going to do that? I mean, Africa is huge and multiple rivers and ponds where these catfish grow. How are you going to achieve your intended solution?
It's very important because we know that 1,000 steps starts by just 1. All right? We've got collaborators across university. In Unisa, we encourage Pan-African collaboration. We've got collaborators across African universities, and then we are trying to reach out, but the major problem is funds. So if we start from the level of researchers, I know we can build it up to the extent that when evidence are produced to governments on what is happening to the public, their citizens, they should be able to take legislative actions or even funding to be able to mitigate that. As I said again, we are looking for collaboration so that we'll be able to produce kits that will be able to do this test on farm, probably start looking at commercialization and all that, so we don't have to get to it. So we get quick results and then something that is very valid. Thank you.
My one last remark, not necessarily question, but have you thought about implementing this into policy and government into like level? Because this ultimately comes to environmental management, and that comes from top tier coming down to the agriculture, down to how we manage land reforms and all that stuff.
Yeah.
So maybe think a little bit bigger, go all the way to the top and start there.
Definitely, because that is the ultimate. There is nothing we could do at the level of researcher if there is no legislation against these environmental issues that will be effective. We have a paper that is in the process, and we made a lot of recommendations at the policy-based recommendations that will be able to mitigate this problem. But then again, as researchers, forgive me, we are limited by those recommendations. The implementation is actually beyond our control. But then we'll be happy to do our parts, and that's what we are doing. Thank you.
Thank you so much, Emmanuel. Moving on to the next one. Sister Nomsa Tabete. Oh, down here. Round of applause for Nomsa.
Thank you so much. Good afternoon. I am going to talk about the air we breathe. Imagine us living closer to the miners. Just imagine us, okay, but the slides are not showing. Okay, should I continue? Okay. Oh, I understand.
The timer is on pause. So we start when you start.
Apologies. I know it wasn't my problem, but yeah, we are very sorry about it. I think I will just continue nonetheless, in the interest of time. I just wanted to show you the slides that I have prepared so that, thank you so much. So, okay. Yes, yeah, I think, I don't know. Okay, thank you so much. Okay. Okay, can I send in the meantime?
They'll sort it out. Relax. Sort it out. This is no reflection on you. It's our technical issue. So don't worry. There we go. Right? Sana.
Can you do last?
All right, cool. I'm happy with that. So because of technical issues, innovation, let us call the next one. Is the next one ready? I think we're ready for that joke, right? Bule? Oh, still invisible. So the next one is Iviwe. Notununu, please come down. While we're sorting out Nomsa, do we have Iviwe's presentation ready? Iviwe's presentation is ready. Hopefully we won't have any issues. Do you have a song, Iviwe, that you, no? No song? Poem? No poem. All right, we are almost sorted. Round of applause for Iviwe, just to encourage him. Thank you.
Oof. Okay. Afternoon, ladies and gentlemen. So my thing here is to essentially say, like we way beyond the R&D component of what we're trying to achieve. So I'm the co-founder of a startup called CAES. Is it low? Okay, is it okay now? Okay, perfect. Okay, yeah, so as I was saying, my mandate is to essentially serve. I'm a co-founder of a startup called CAES. We've had some assistance from the DITTC through the Univentures. So South Africa essentially has issues around waste management, energy poverty, as well as sustainable food production, right? And the people who essentially suffer the most are essentially the ones within the marginalized communities, townships, rural areas, and also peri-urban areas as well. So biodigesters have been proposed as they essentially address all of these three issues at once. However, the biodigester industry, especially at the smaller scale in South Africa, is quite small at its infancy, right? But the focus is on larger scale biodigesters. And even the biodigesters that are essentially available are quite limiting in where they can be placed, to a point where their focus has been implementing these within the rural areas through government-funded projects. But we at Akea Eco developed low-cost, easily implementable, and also easily transported biodigester solution. So what you see in there, that's essentially our biodigester, a 2 cubic meter biodigester can essentially produce, at specific size, can produce at least 2 to 3 hours of cooking gas on a daily basis, and more or less 17 to 25 liters of organic fertilizer on a daily basis. So we decided to partner this biodigester system because essentially we wanted something that would be flexible in terms of where it would operate. Either you're in the village, either you're in the urban space, but it should be implementable essentially in all of these sites, introducing that flexibility. So it's an easy setup. You can set it up within an hour, and you just wait for it to start producing that gas and also that organic fertilizer for you. So we decided to also partner this biodigester of ours with a vertical hydroponic system, since we wanted to introduce it within the urban setup. Now, we decided on vertical because it essentially maximizes space. If you notice, we don't really have a lot of space, land, to essentially grow crops within the urban setups. So that's essentially one of the innovative ways where we imagined the biodigester working. If I can just give context, I have a system, but I don't have land to plant. So I was producing all of this organic fertilizer, but I was just chucking it down the drain. But now we've essentially built a process, or came up with a process that allows us to use that organic fertilizer on the hydroponic system itself, which is something that hasn't been done essentially on a commercial basis. I just wanted to highlight as well, like I said, we're beyond the R&D component. These are essentially pilot sites with a rural setup. So let me just look for a point. Yeah, so we have a rural setup here with Tate Matindao here in Krugersdorp. Here we have a township setup in Vlakfontein towards N1 if you're going to Vereeniging. And this is essentially a setup at my house where I essentially have both systems. And this one is a community-based setup where there's also youth development training that's essentially also involved within there. But all of these are essentially producing gas where these households are cooking, and also the organic fertilizer where they essentially using it to grow their own crops. I just want to play this video. There's no sound. Yeah, but I'm sure you can see it in action. And this is at home, please.
Yeah, thank you. Thank you. If we're is it a commercial product or you just distribute it to communities? And if it's commercial, how is it doing on the market?
Yeah, it is. It is commercial. What I just showed there was essentially a pilot project where we wanted to show that it does work. Doesn't matter where you are, as long as you have the waste to feed the system, it essentially works. So you can contact us directly should you want the product itself, but we've also created partnerships currently, like Madam Waste, who's in Pretoria. They essentially champions within the circular economy space. We've essentially became their technology partner. They were just missing the biodigester component there. So you can also approach them, and then they link us up with you. But we've seen, especially like within we've been engaging with these communities. It's still above what they can possibly afford. So we're also looking at engaging government, but also we have engaged already with potential NPOs, like with the setup, the community-based one. That's essentially through an engagement with one of the NPOs who's been engaged with us.
I think this is awesome. I think this is really driving towards the new trend of AI farming. And it's pretty nice to see from lab to market. Congrats for that. My question is, have you thought about going upscaling in commercial, meaning that have you approached your Sakata, your Captiva, your ZZ2, those particular clients who need to produce bulk seedlings and could use something like this on a larger scale and more reliant cost, run rate business? That could also be an avenue for you to explore and ultimately help fund the smaller areas and upscale them as well.
Yes. No, I like that initiative. But the idea was to try and scale up slow. So we have had engagement already with farmers, with farmers who are growing crops, and most of them, weird enough, are essentially ones that are growing chickens, especially for the heating component part of it. So there's definitely movements towards that side of things. But I think the guys you mentioned are still quite big and too big for us to start approaching. But once you start building a portfolio, you don't think so? Okay.
Hi, Iviwe. Thank you for such a great presentation. I just have one question. Your biodigester, is it just only limited to the production of biogas, or it can also do bioethanol?
No, it's just biogas at the moment. I mean, what we're focusing on is the cooking aspect, but now we're exploring heating. If you wanted to heat your home, it's winter now, but also exploring water heating should you want to replace your geyser, but simply just biogas, replacing the LPG part of your household.
No, thank you. But you also mentioned that you're working with DITCC. What is your implementation plan regarding this? I know it's on the minimal production of your biogas, but what is your implementation plan if you want to take this to the rural community? for example?
You mean okay, so the system I showed is a household-sized system for 2 to 5 people, right? But we have larger sized systems as well, a 4 cubic meter, 6, as well as 12, that can essentially support larger households, or essentially support a farm, a restaurant even, depending on the type of waste that they have. Our question is simply, how much waste do you have? And we simply recommend the right-sized biodigester system for your house.
Thank you.
Thank you.
Thank you so much to all our speakers and presenters. There's something I think it will be a mistake if we do not mention this. And I'm saying this because my biological father is a pastor, Mfundis. So he preaches a lot. And you can give him time, but he always uses the excuse of being led by the Spirit. So, and he exceeds the time limit has been given. So congratulations to all our presenters here for keeping to time. And we hope that this continues. To the observant one, maybe you've noticed that amongst the questions being asked, there's an additional voice that you have identified. So that is the voice of Prof. Mutumun. So she was a bit delayed. And Prof, maybe just to make mention of this, the judges all introduced themselves with a 3-second dance. So we'd appreciate to see your dance as well. You can do the Macarena, it's okay. Anytime, Prof.
Oh, wow. As for the dancing, I don't want to embarrass myself. But however, I am Professor Mutumuni Managa, based at iNanos. I'm a professor of nanostructured materials. Thank you.
Thank you. Thank you and welcome. And again, moving along, we will have our next presenter, Marty Helena Westhazen. And also to mention that the presenters, they are really aiming to achieve best presenter because there are prizes and awards at the end. I noticed what Emmanuel did. Emmanuel deliberately created a new word for us. Instead of saying researchers, he said researchers. I don't know what the word was, but he wanted to be memorable, and I think we're getting the same thing here. Thank you.
Okay. Can everyone hear me? No, it's fine. Thank you so much. Okay. Many pharmaceuticals are still being created using traditional chemical synthesis methods. These methods require toxic solvents, harsh reaction conditions, they require high energy, and they create environmentally dangerous and hazardous waste. But in a world that's moving towards sustainable solutions and green productions, we have one question. How are we going to create pharmaceuticals in an efficient and environmentally friendly manner? Good afternoon, all. My name is Marty Westhuizen, and I'm a master's student here at Unisa. Biocatalysts, that is the reason and the answer to our question. Biocatalysts are enzymes that are naturally derived from, for example, plants. These enzymes can be used to create pharmaceuticals in an environmentally friendly manner. They can also create pharmaceutical building blocks. My research focuses on one of these biocatalysts, a novel hydroxynitrile lyase enzyme. This HNL is derived from a cyanogenic fern, Phlebodium aureum. It is super important in industry because it creates something called cyanohydrins. Now, cyanohydrins are building blocks called beta blockers that create medications like high blood pressure medication. My research last year in my honors year focused on expressing this enzyme using bacterial expression systems. But I realized there's one problem. These bacterial expression systems are not scalable for industrial use. Yeast expression systems, however, are. Not only can I upscale my production to use in industry, but I have a better folding of the enzyme, I have better stability, and better secretion of the enzyme. My research focuses on more than just looking at the expression and the characterization of the enzyme. It looks at the environmental impact of green pharmaceuticals and biocatalysts. My research is not the problem. It does not condone this future. It condones this one, where green biocatalysts are used and creates pharmaceuticals in an environmentally friendly manner. With assistance, this project can be much more than just a small lab-scale production. It can go to industrial applications, and it can add to South Africa's growing presence in biotechnology and biotechnological research whilst being environmentally friendly. Thank you so much.
Marty, thank you for your presentation. My question is, based on the feasibility and the realistic point of view of your project, how realistic is it if, let's just say, you want to take it to the market?
I think it is quite realistic. I mean, the costs to start this as an industry is already so small. You only need a small little vial of enzymes, and that can be reused multiple times to create the beta blockers and then the pharmaceuticals. So it is, I think, realistically very obtainable if we do get the expression at the level that we want to do with the yeast expression system.
Thank you.
Hey, Marty. My question is, how does this particular project play in the big field of precision medicine?
That is a very interesting question, and I'm actually not so sure because my main focus is more in the lab at this moment, and I looked at the environmental impact and the cost. I didn't exactly look at the medicinal standpoint.
I think it's a good aspect to look at, especially now that the world is sort of going towards multi-omic facets and pharmaceutical companies looking and driving specifically towards personalized medicine. If you can get in that manner and start pinpointing precision towards different groups of medication, I think you'll go very far.
Thank you. I'll absolutely look at that. Thanks.
I don't have a question. I think it's clear and it's well stated, and especially the fact that you're still at the beginning stage of your project training, correct?
Yes, yes.
All right, that's fine. All the best.
Thank you so much. Thank you.
Thank you, Marty. A round of applause for Marty again. As we move over to our next presentation, I would like to call on stage Sanette behind the pillar, Caro. A round of applause for Sanette, please.
Yes. Thank you. Good afternoon, everybody. The title for my presentation is A Geographical Perspective of At-Risk Students in an ODEL Environment. We are a research group called SPACE with Prof. Ashley Gunter as the project leader and Dr. Sabello as the team leader and a whole list of minions. So student attrition and academic performance are influenced by location and socio-economic activities. Yet there are very few studies in South Africa focusing on this important aspect. While a rural or remote background may have limited impact in in residential universities, this becomes quite a challenge in an ODEL environment where infrastructural inequalities are coming to the foreground. Previous studies also emphasize the importance of a spatial perspective when compiling student profiles. Therefore, the aim of our research is a spatial perspective to determine the socio-economic backgrounds of students registered for semester 1 2025 at a college at the ODEL University. As such, our research aligned with student support and co-curricular activities, catalytic niche area, and we contribute towards SDG 4, quality education. As a first step, we geolocated all the students registered at the college according to their postal codes. From that, we extracted all the students who are flagged as at risk of dropping out of the system, and these students are identified by the university. We then used the GIS to calculate kernel densities of areas where according to the number of students and also according to the number of modules for which they are registered. We then extracted the upper 50% of these hotspot areas. We then combined the two layers to represent the areas where these students reside. We divided these areas into metro areas in red, towns in orange, and rural areas in green. We obtained lifestyle data from a private company, and we used that to extract the socioeconomic backgrounds of the students. The descriptions were then put into an AI image generator to give us a photorealistic representation of these students. The results highlight the daily challenges faced by these students, including poor mobile internet connectivity, long travel distances, reliance on public transport, household incomes, and socioeconomic vulnerabilities. In contrast to previous studies, we have found that it is not only students in rural areas that have challenges, but also students in cities and towns, although to a lesser extent. We also know that recent studies has indicated that access to higher education is challenged by students if their basic needs are not met. So we have to find ways to accommodate these students, to assist them to pass through the system so that the university can retain them. We acknowledge that our study still does not include the student voices, and this will be done in a follow-up study. We had workshops with staff members. We presented the results to them, and they contributed by telling us how we can feed this information into better curriculum transformation. The presentation by Prof. Schmitz will elaborate on these results. Thank you.
Before we hand over to the judges, may I please ask that the audience please give whoever's in front the respect that they deserve. It's nerve-wracking already to be there, so now to have a bit of disruption for the audience is not great. So may I please ask that we keep it quiet until they finish. Thank you.
I think the issue is that the secretariat can please stop with the bags for now, because people are presenting their work and they need to be listened to. So the secretariat with the bags, I'll stop it for time. Thank you.
One of my questions is, I saw that if you look at your map, that Gauteng and Durban was quite heavily, maybe because there's more data, but why is Northwest and the Free State underrepresented, or am I missing?
Yeah, if I could go back to that map, you will actually see that.
Yeah, let's go one on.
This one.
No.
So
Next
it
one.
actually lines up. It lines up with the first one that actually shows the college students. So there are less students in those areas, so there will be less at-risk students. There are two interesting spots coming out in the Free State. If you look at these maps, that in those communities, they're Allen Rich and Frankfurt. For some reason popping out, it seems it's social vulnerabilities, socioeconomic vulnerabilities.
Because
so
I
it
know-
aligns with the student numbers.
Because I think there by the Northwest is Northwest University that has two campuses, and then, Mafeking and then Porch.
Yeah.
But yeah, it's...
Yeah, that is the profile of our students.
Okay.
So I was going to ask the same question to say, you define small towns as in the former Eastern Cape towns, because I was wondering why nothing in the small towns of Northern Cape, Western Cape, and other provinces, but you have explained that it's the numbers of students that Unisa has, but one student is worth any effort that Unisa can put in to make sure that student succeeds. So as you craft your project, think about that one single student has an equal right to the goal or sitting number somewhere.
And it's also less dense populations, so we will naturally have less students with those.
Thank you for such an informative, I was not aware of that type of information regarding the students. But then my question says, with this type of information, then what to the university?
Yes.
What is it that is being done with this data that is generated?
Sure. So there's a big drive, as you know, within the university for curriculum transformation. We felt that the current curriculum transformation is based on theory, without understanding where our students are coming from. So that is the next step that Prof. Schmitz will present, where we as now engage with the staff members to see how this information can be contribute towards curriculum transformation. We can't do much about the socioeconomic backgrounds, but we can try to accommodate them by, for instance, should they need to travel to a specific location to submit assessments and not travel a week later again, to see how we can accommodate. Okay. This has to quick.
Thank you so much, Sani. So we're going to move on to our next presenter. The next presenter is Bridget Nyobe. Let's welcome Bridget with a round of applause.
Good afternoon. It's Bridget Ngobe, not Nyobe. Okay, thank you. I usually go through that problem. So my study is about antibacterial and phytochemical evaluation of Maria angelensis and Asparagus falcatus. The World Health Organization in 2025 reported that about 1.14 million patients who were given the antibiotic to treat Neisseria gonorrhea developed resistance, which 550 million of them were only treated. The remaining patients had to develop antimicrobial resistance. That's how I identified the research gap. So perinatally transmissible bacterial infection also target the pregnant women and the newborn. About 45% of neonatal deaths are caused by these perinatal transmissible bacterial infections. And the other one was Streptococcus algaceae, which are also identified as the research gap because it's not even screened in South Africa or even in African region. So we identified that research gap that we need to identify the targeted bacteria. Why is it not screened in South Africa? Hence, we have the neonatal death that is still always arising. This study, or as I mentioned, seeks to bridge the gap using the medicinal plants. We're going to be using Moria angelensis and Asparagus falcatus to combat the perinatally transmissible bacterial infections because traditionally, currently, they use the antibiotics, and there is a recent rise, or which has always been there, of antibacterial resistance. So we have the prenatal data against the Neisseria gonorrhea we used the tetracyclines, and we learned that the extracts that we used to treat using the medicinal plants and Neisseria gonorrhea, it was Neisseria gonorrhea, and we use tetracyclines and penicillin and medicinal plants. The ones that we treated using penicillin, after 7 days, the bacteria was growing again, and the ones that we treated using medicinal plants, the bacteria was not growing again, which shows that these medicinal plants will bridge the gap. So this study aims to improve the health of maternal and neonatal health care, to reduce the dependence on synthetic antibiotics, as to combat the AMR issue that the World Health Organization also mentioned, to contribute to antimicrobial resistance management, for the potential of development of drugs using medicinal plants at the end that won't have an antimicrobial resistance problem. So we're gonna need sponsorship funding for the research, and also partnership with the Department of Health, because at the end of the study, we're gonna be needing samples from the patient to identify really what bacteria are living in the samples that some of the patients are being treated using the traditional medicines from the traditional healers. So we're gonna need to conduct that study using the human samples, not using the human cell lines as we're currently doing. And we're gonna need clinical validations and field studies, intellectual property protection, because at the end of the day, we're gonna develop a drug to treat these infections that are mentioned. Thank you.
Thank you, Bridget. My question is based on when you're extracting these phytochemicals from the plants, have you identified which specific ones will be active against this specific bacteria?
Yes, we have identified the roots and the shoots from the Maria angelensis, so the actinoids and the flavonoids. So we have identified which ones we'll be using in the lab. Yes.
Hi, I think this is an awesome project.
Thank you.
I've sort of got a two-part question. First part is, you've now told us what you've done now, and you need funding and stuff for the next part of your project. What is the next step in your project? Because you've told us the overview of where you want to get to.
Okay.
But like our previous speaker said, 1,000 steps starts with one. So what is the next step? And then I'll go on to my second question.
Okay, the next step will be to identify the bacteria that are living inside the samples because the problem that I identified is what they call Magokonia invenda. So these women go to traditional healers and they remove something to treat that infection so that the newborns do not suffer from neonatal sepsis or neonatal death. And it's effective. The medicinal plants that they use to treat that, they're very effective. So I had to use my scientific brain, or I need to identify the microorganism that is living inside of those things that they are removing from those women to treat those infections. So we will need to identify. That's why I will need the partnership with the Department of Health at the end of the study.
All right, so we're going to be diving into a multi-omic type of avenue.
Pardon?
So you're going to be diving into a multi-omic. So with genetics and metabolites and all of that stuff. So my other question is, have you thought about joining with a medical university to get access to clinical trials and to patients that can go through this? Because you're going to need a lot of authority and regulation. There's a lot of red tape when it comes to testing anything.
Yes. At the end of this study, I'll need 30 traditional healers, 30 medical doctors, and 30 samples from the patients who are treated using the medicinal plants, and 30 patients who've been treated using the synthetic antibiotics. So yes, that has been identified already.
I think the best bet would be this. They have a very big department that's in an innovation drive to use medicinal plants as emerging medicine.
So I'm more than happy to help you out there.
I went VETS, but I did apply at VETS, but no responded regarding the project. So I wanted to try the other Sefako Mahato. They were giving us a go-ahead that side. So I'll talk to you after regarding VETS. Yes. Thank you. Yeah, thank you.
A quick one, I think I don't have time.
Yes.
If this plant works in its natural form, in mixture or whatever, why do you want to extract it? Why do you want to get it flavorant and all those things?
I mean, hello?
If this plant works in its natural mixture with whatever it is that it mixes with,
yes.
Why do you want to go to separate flavonoids and whatever, anthocyanate and so forth? Why do you want to do the separation of these molecules?
Oh, because currently the problem that I'm identifying has been identified as a problem affecting those women in low set resource areas. So at the end of the day, we need to have a proper drug developed using these medicinal plants. So we had to go the real scientific rule. Yes.
Thank you very much, Bridget. I'm not going to try and pronounce your surname. May I call next? Are we ready for him? Yes. May I call next Olwa Stephen Olawuo to come on stage? Round of applause for Ola.
What about this?
Good afternoon, ladies and gentlemen. Okay, good afternoon, ladies and gentlemen. Our research is about the assessment of biological activities of Jatropha gossiflora and Osimum gracillium leaf extract against clinical E. coli isolates. A peaceful ecosystem was disrupted by fire. Everything burned down, only plant survived. Forest revived. And what we can see is that no circle of life without plants, which has led us to these projects. AMR in E. coli infection poses a very serious threat to poultry health and public health. We need cost-effective therapeutic strategy to combat this menace, because the infection causes substantial economic losses in poultry production. It also threatens public health. Among concern is antibiotic residue that is found in eggs and meat, and persistence of these bacterial strains in the environment. So this leads to proposed development of macro and nano encapsulated phytogenic feed additives as alternative to antibiotics against E. coli infection. Plant extract demonstrated very strong antibacterial and antioxidant activity with promising selective index against E. coli. This strategy is going to reduce antibiotic use and address AMR in poultry and human health under One Health framework. Our solution is plant-derived. That is why it's better. It's plant-derived, cost-effective, and can deliver intact active ingredients against our target pathogens. Furthermore, this solution enhances poultry and public health. It increased productivity for farmers and industry stakeholders, and it supports commercialization of these feed additives. Progressing the innovation, it requires funding, industry collaborations, and IP commercialization support to facilitate in vivo validation, formulation, toxicity assessment, and large-scale poultry feed trials. Ladies and gentlemen, researchers of high repute and industrial stakeholders, these two medicinal plants can serve as multifunctional alternatives to conventional antibiotics and antibiotic growth promoter. Thank you.
Thank you, Ola. Clarity for me, what exactly is your innovation here? Let's do it again. What are you coming up with when you see the problem and we see what it can do, but what is it?
It's about the development of these medicinal plants as feed additives to combat E. coli isolate, which is very stubborn in poultry production and might complicate it.
I can see why you went for the poultry industry because it's quite lucrative. My question to you is, being from a poultry industry myself, and I was born and bred in it, it's a very close-knit community. And my question to you is, how do you plan on breaking into the market with these additives coming in with antimicrobial resistance and helping the healthcare of the chickens and preventing economic loss? If you were to go commercially and go through all of the stages, getting there and what is it, FDA approved and stuff like that, how do you plan to get into the market?
Okay, thank you. We've done preliminary findings. That is why I mentioned that it has good antibacterial, good antioxidant potential, with good selective feed index. We've checked the safety using mammalian cells, ferromonkey cell lines, and caco cell line, which is intestinal. So the next thing is the formulation, which can be done with organizations like CSR. Then after the formulation, we move to the large-scale feed trials, whereby we use a specific number, depending on the available funding, specific number of broilers, and we will just put it in the feeds to reduce the contamination of this E. coli in their system, especially GIT.
Okay, my second question is, would you implement this at chicks or when they're already established? So at which point would you intervene this extra additive?
The extra, okay, the feed additives.
Yeah.
No, you started the feed additives right from the beginning. You know, when we are talking about broiler, you have broiler starter, you have broiler growers, then you have broiler finishers. So there will be specific inclusion rate in the feed, and you have to feed them throughout in order to reduce the guts, the gut contamination, and it will never now transfer to the egg and meat so that it will not cause public health challenge.
Ola, thank you. Please correct me if I'm wrong.
Okay.
As far as I know, what are the poultry, the poultry that is being fed currently, it contains antioxidants as well and antibacterial additives.
Okay.
So what makes yours different from what is currently available and that is commercially available?
Okay, thank you. In the food currently, we have antibacterial, we call it feed grade antibiotic. They call it antibiotic growth promoters, but it's synthetic. You know, it causes a lot of residues. The residue goes to the meat, go to the feed, and it causes antimicrobial resistance in human being. So our own option, solution, is plant derived, doesn't have any form of won't pass any residue. There is environmentally friendly and is safe. You know, the synthetic worm is dangerous, causing more havoc on the human being, who will be the last consumer of these eggs and meat. So most of the one that we have is synthetic. And you remember in 2006, European Union placed a ban on the use of antibiotic growth promoters in the livestock production. That is why they cannot import meat from any country that doesn't align with their policies. Thank you.
A round of applause again for Ola. Thank you. And colleagues, let me extend my gratitude again to our conduct. We've been very attentive, and to all our presenters, thank you so much for keeping to time. Again, we're going to move on to the next speaker. I know this surname because in our slang language, it means someone who's really powerful. So, so again, I'm hoping this next presentation will be, or rather will live up to the expectations. Can we welcome Refilwe, given Kudumela?
Good afternoon, ladies and gentlemen. As introduced already, I am Refilwe Kudumela, a PhD student in the Life and Consumer Sciences Department, and I'll be talking to you today about part of my PhD project titled Exploring Endophytes and Medicinal Plants as a source of potential bioactive compounds to combat antimicrobial resistance. Now, antimicrobial resistance is actually a phenomenon where microorganisms are becoming resistant to the antibiotics that they were usually sensitive to. This can happen either through the misuse or overuse of antibiotics. And this misuse or overuse can be when we use antibiotics even when we don't need them, or when you don't finish the prescribed course. Now, this is a global health problem, necessitating the research for alternative sources of treatment. And this is why we are now looking at medicinal plants and their associated endophytes. Medicinal plants are commonly used by people, especially those residing in traditional settings, rural settings, mostly because of their affordability as well as accessibility. And we are trying to validate scientifically, we are providing evidence how this medicinal plants brings about the healing. Now, endophytes are classified as microorganisms, which are fungi or bacteria that inhabit plant tissues without causing any harm. And these are believed to influence the healing properties of these plants. So we are seeing that if we are to go the route of getting bioactive compounds from plants to serve as lead compounds, we might tend to run the risk of over-harvesting plants. So that's why we are introducing the concept of endophytes, because if you have medicinal plants and endophytes that are producing the same enzymes, so endophytes can be grown and even at a large scale. So now, these endophytes are actually positioned as a sustainable solution for a large-scale production of bioactive compounds. Now,
so this is the innovation part of my project. And we've had, we actually selected 3 medicinal plants, and the medicinal plants are Cochrane stridens, Terminalia cerevisiae, as well as Pterosclerosus echinatus. So the plants, we are actually studying them individually, and then we combined them, and then we also studying the endophytes that are associated with them. So there has been some activities that we have observed in both, specifically focusing on Cochrane stridens. So both the endophytes in Cochrane and the plant itself are producing antimicrobial compounds. So what was also interesting is that they also have antioxidant properties. So we are targeting compounds that will have a sort of a dual mechanism, so that now you not only combat infections, but you're also trying to sort of fight the oxidative stress that is associated with bacterial infections. And the outputs of the studies were presented at a local conference in 2024 and also at the Innovation Festival. And we also published a review paper on this. And yes, as I said, there is some traces of antimicrobial activity. So this plate here is just a summary of the results, some of the results that I got in the lab. And we are also targeting compounds that will be less toxic to normal cells. This is why we are also running cytotoxicity assays. Thank you.
Thank you, Refule. Out of curiosity, are you working with any traditional healers in obtaining their indigenous knowledge regarding these plants?
No, we are not. We are currently relying on literature. So we are looking at some of the reviews that have been published about medicinal plants that are effective. So we are looking at that and we are seeing the gap. So with Cochrane is actually an edible plant. I don't know if you guys know it, but in my language, we call it telele. So, yes. So it is an edible plant. So there were some reports that it has some antibacterial properties, and also some traditional healers are actually using it to treat sexually transmitted diseases. However, they are combining it with Terminalia. So our approach was also to say, okay, let's combine and see if we'll be able to get the effect that the traditional healers are saying. They induce. And it's said that we did not establish any interaction. However, this will still serve as knowledge to them that, okay, we have tried to test this at a lab scale, and this is what we find out. And they'll do whatever they do with that information.
Because honestly, it will be quite very interesting to actually include them in this, because I am a believer in indigenous knowledge.
True.
Because that what also enhances our knowledge in most of these plants that contains medicinal properties. Thank you.
Thank you.
So what's next?
Glad you asked. Next is getting my PhD. Well, but other than that, we plan on doing in silico studies, and then from there, judging from whatever that we'll get, then we'll do in vitro studies, and then we can we can approach the CSIR and do the formulation. We had an interesting talk by Dr. What's her name again? Dr. Maphalala. Ramalapa, yes, it was actually quite interesting that they are actually doing formulations. So that is next. And also working with traditional healers, because we are actually a group of students and postgraduate postdoctoral fellows. So there is a bigger picture of, okay, we have this medicinal plants that we are studying, and it would also be interesting, like you are mentioning, Prof, to also rope in the traditional healers.
two-part question. First part is, am I correct to say your research focus is on the endophytes that may produce these chemicals, not on the plant cells, right?
Okay, my project is a three-part project. So I started first by assaying the plants individually, then combining them, and also I also cultured the endophytes, and then I ran biological activities on the endophytes. And then I'm going to compare if the activity that we see on the individual plants themselves is the same as the endophytes, so that we can now draw a conclusion if it is advisable to stick to the endophytes, which are a more sustainable approach, or if we can still go the traditional route.
You've answered the second one, because I was going to ask if you've done any comparative studies on the endophytes and the plants, whether in combo or individually, but you will.
I will. It's part of the process. I have just now done the antibacterial studies on the endophytes, and the activities are not comparable, but there is still antibacterial activity.
Thank you. Thank you so much, Rufilwe. And our second last presentation is by Peter behind the pillar Schmidt. A round of applause for Peter.
Yeah. Right. I'm Peter Schmidt from Geography, and I'm now in front of the pillar and not behind it. And I'm also one of the, when they put up the slide, I'm one of the minions listed right on the top there. All right, so as Dr. Caro indicated, that we looked at the geographical distribution of our students at risk, and what we've done then is we presented our results to colleagues. We had 4 workshops, and we want to now see what our colleagues experience, why these students could be at risk and so on. And so we had the discussions with them. So we conducted 4 workshops over the course of weeks, and the total number of academic staff and lab staff that we had discussions and interaction with, it was very informal, it was very informative, and it was over 61 academic staff and laboratory staff. And the sessions were about 1.5 hours each. Right, so we had then these 4 questions that we asked them, and what do you think we can, from our lecturers' viewpoint, assist these students, what positives can be done from the lecturer's side, and also what barriers do we as lecturers experience to reach these students and to help them and to improve their throughputs. But also we took into account the institution that we work with. So some of the stuff we as lecturers can address, but other stuff the institution needs to address, because it is institutional issues and not lecturer issues. And then we combined all the results from the discussion, and this is then the results. So one of the big problem is our assessments are very rigid. So they suggest that we put in flexible assessment practices. We must have clear communications with the students. Pre-recorded lectures and mobile-friendly content, because some of the people don't have laptops or have a difficulty to access the content via laptop because of internet access and so on. Also, maybe alternative communication platforms where appropriate. It could be also that, sorry, I'm going to use a very big swear word, Starlink. So they could be a possible source. And also the lecturer availability and expectations that we need to communicate with the students and so on. But the module restructuring is very important. I think our semester system that we have now, based on the feedback that we got from our colleagues, is that it is too short. And we try to compress a lot of information within a few weeks and so on, and late registrations and so on, which have a massive impact. So maybe going back to the year module, or even a super semester with a summer school would be maybe a better option to address our student needs. Right, the barriers is high data connectivity cost affecting student participation. So the students don't actually engage because of data issues. Also misalignment between lecturer roles and student expectations. Some lecturers felt that they have to do much more trying to solve the students' psychological problems and socioeconomic problems rather than addressing the students' need to understand the context that they teach and so on. And also the late registrations is a big negative, and that disrupts our teaching and learning processes, and most of us who sit here will identify with that problem. Right, institutional barriers is some of it's repeated, but from an institutional viewpoint, but we need to have a systemic, data-driven and oriented support interventions, real-time tracking of students so that we can monitor their progress. Maybe it's through dashboards and stuff like that. Or we can use chatbots. I used large language models to have a discussion on the module content. We can use that. Improved communication between and awareness of existing support systems and so on. One of the things of the University of South Africa is they don't communicate very well. And I experienced this yesterday again. Right, so the barriers is also then language and communication barriers. But one of the big no-nos that came out of our discussions was high staff workload and large enrollments and limited staff infrastructure capabilities. And one of the big things is that our student ratio is very high. So they say we must do personalized interactions with these students, but if you sit with 3,000 students or 5,000 students, how are you as a single lecturer be able to do that? So that is also one of the things that came up. Right, so to summarize, findings suggest that the curriculum transformation should not be just on the theoretical content of the material that we teach, but also flexible and accessible delivery practices. We proposed module-level interventions include mobile-friendly study materials, revised assessment timelines, and improved communication practices. Institutional recommendations include improved internet access, data provision, structural adjustments to semester delivery, maybe year modules or super semester with the summer school. And we must emphasize the need for contextually responsive curriculum practices that accommodate students' lived realities, as indicated by Dr. Caro. And I say thank you very much for listening. Questions? I don't know if I can answer them, but please fire along. Yes.
Yeah, I am not sure if maybe I lost you somewhere along the line. Correct me to say the problem was identified by the previous project by Professor Caro, right?
This is a continuation of that.
Exactly my point. So you are taking the problem identified and trying to provide a solution in the next project. Why don't you just combine the two projects for the sake of this exercise?
It is actually combined in practice, but we split it up into two for this particular session.
Okay.
Because otherwise we would have been over the 5-minute limit.
My question's more broad. If you were the boss, how would you solve this particular dilemma?
Okay, the first thing I would do is I would change from semester to year modules and include the summer school for those students that are flagged as at risk and so on, and then they have to attend it via online and so on. So that, in a nutshell, I would do.
And then how would you strategically manage that?
We've got management systems like Moodle and so on, so it should be easy to do because Moodle is open source, first place. It is very easily to restructure and reform, make it customizable for each of the modules because each module is unique on its own and so on. So I think the systems are there. It must just be made more reliable. And also one needs to not be too prescriptive to the lecturers because they understand the context of their field of discipline and so on, and also how their students react. But one of the other things that we picked up is that participation rate of the students at the moment are very low. And that is a very difficult thing, how to motivate the students. Maybe by example, when their fellow students participate in the summer school or something and they perform much better, it could be kind of a knock-on effect, snowball effect, that they see, but my friend is doing this and look how his marks improved and so on. So this kind of positive feedback and psychological manipulation. Thank you.
Thank you. You mentioned chatbots as one of the suggestions in terms of improving communications with students. Did I get that right?
Yeah. There's a project that's a spin-off from this, which are busy now looking into the possibility of using chatbot to help students. So that it's like when you go to a banking app and so on, you'll see this little lady there, hi, I am Nokutula, how can I help you, and so on. And that kind of setup to assist students in frequently asked questions and things like that. So the chatbot is a kind of assistant to the lecturer. That's the kind of idea that we want to look into.
It's an idea, not necessarily that it's.
Yeah, well, there is a project that they're starting to look into and to develop and looking into how to implement it.
Okay. How effective? May you elaborate on the effectiveness of your suggestions?
Yes, the geospatial analysis that we've done is now being completed. This first workshop is done. It's a multi-year project, so the chatbot will be in the next year or the year after. So we don't have yet any comparisons. So it's still in this little infant phase.
All right, thank you.
Pleasure. Thank you so much.
Thank you again to our presenter. And we, colleagues, have come to the last presenter for the day. Thank you so much for your patience. And I know previously we had technical issues. This has since been resolved. And prepare to be blown away.
I am there. And good afternoon, once again. I am not going to let these technical issues intimidate me. Nonetheless, I'm going to. So it looks like these challenges. I tried to bring my lecture with the physics. Okay, I am going to talk about the air that we breathe. So imagine ourselves living next to the mine house. But why? Why is that a problem? The problem is about the air that we are breathing, because it is not just air. It is polluted air that has particles from this mine dust that enter into the lungs, and they get to cause the respiratory diseases and cancer, and our children and the elderly become so vulnerable as a result of exposure to these particles from the miners. We have noticed that we have these big problems that is affecting the community. Now, the solution is we need to get the communities to know about what is in the air that they breathe. So we have noticed that most studies have used very expensive monitors to monitor the particles in the air. and some have only looked at the transport of these particles from one point to another. So what makes our study so unique is we make use of the low-cost air monitors and deploy them around the source, which is the mine dump, and the receptor, which is the community. We then determined the transport of these particles from the source then to the community. We then identified if these particles are really coming from this mine dump. Remember, in the air, we have a lot of particles, and you cannot tell where those particles are coming from. So with ours, we then identified these particles are coming from this mine dumps. We then looked at the human health risk assessment, and we applied that model. So we considered all factors of exposure. We then did as much as the community is exposed to thin concentrations of particles, the community will be affected individually. So the children and the elderly will be more affected at every exposure to that particle. We do not just want to measure the concentrations of particles in the air, so we wanted to make an impact. We wanted to have the research drafting plans, policy, and decision making, especially regarding the exposure of particles from the mine dumps. We want to empower communities that are staying next to the mine dumps. They need to know the air or the concentrations of the air pollutants or particles that they're exposed to on a daily basis. So our main aim is to improve public health, and we need to support environmental justice. Colleagues, I have so much to tell you about the work that we do, and should you wish to contact me or collaborate with me, please do scan the QR code, then we can take it from there. And thank you so much.
Thank you. Indeed, you didn't allow the technical glitch to intimidate you. My question is, may you please elaborate more on how experimentally, I don't know if maybe you've done that, quantify and identify these particles that are in the air?
It's like, first, okay, like you mean the ones that are coming from the mine dumps, or how we...
Yes, the ones that you spoke about. Yes.
So at first, like now, we use the monitors. The monitors will then give you the real-time data of the concentrations of the particles in the air. So now we then interested about how or what are the factors that will affect this particle transport from one point to another. So what we then apply models and put in all meteorological factors that might affect the transport of the particles. And then now we apply other models as well to verify where all those particles are coming from. And thereafter, we apply a risk assessment model where we look at this particles that are causing so much health issues are really coming from this mine dumps.
Thank you.
Congrats with all the technical difficulties, and also to Sanette, who also was the distraction earlier. I know how nerve-wracking it is. My question is, what do you want to do with this? So you're now at the rural areas with these mine dumps, you know the exposures there. You can't replace air. You can't install a monitor in every household. So what's the plan of action? What's the plan for innovation besides from, environmental management? What's next?
We want to bring everyone together. We want to work with industries. We want to work with regulators. We want to work with communities to try and reduce this particular pollution to as low as possible. So another thing that we're planning to do is to get funding and have monitors that will be deployed on communities. So communities will have access to real content. So they will also have an impact in knowing the amount of particular conditions they exist to and how to price reduce regulation.
Okay, so my second question is, these mines also have a responsibility to keep their communities clean and, healthy and all of that stuff. They have environmental laws and taxes that they have to pay. So with these monitors that you're implementing in, is this to keep the mines in check? Or how do you plan to improve the community which is affected by these mines?
The mines are really doing their best to try and control or really protect the of the planet. It's just that it is not sufficient if they're doing it alone. So we want or need to come together and help them as much as possible. So the regulators are already regulating the mines, and they have set certain limits for them to comply with. So we have noticed that now even with those limits, some of the communities will get even close to limits to lower ones. So we need to work with the regulators as well as the mines to try and reduce those levels as low as possible.
Yeah, thanks, Dr. Tabet. I suppose my question is similar to hers, that I'm still failing to see where then does innovation begin. There's data capturing and collection of the particles in the air that we know that these mines are polluting the environment, the air, and the waters that we drink. And your title says the air we breathe. Does your research only ends to identifying and quantifying the pollutants in the air, or is there a way beyond that to then say, what are the solutions on an innovative point of view rather than policy? Because the mines dump and they know that this is pollution. Air, the soil, the water is a given. Is your research go to a certain point where it then says, these are the practical solutions that we can do? As she said, the air is air, we can't replace it. And the mines, the dams are already there. And mining is going to continue forever. Where is the innovation coming to take the problems and provide a solution?
Apologies. I just wanted to come to this. So there are best practices around the world that one should bring to our country. So yes, they are expensive. Costs they don't want the industries to turn out. So we want to bring it together with the government, that now the research institutes to apply for funding, to help bring those best practices to our in South Africa, especially in communities where there are mine diversities.
Thank you so much, Nomsa. And we've reached the end of our sessions, our pitching sessions. A round of applause for all our researchers who are striving to find solutions to societal challenges. So the next step is that our judges are going to huddle up, they're going to deliberate, and they're going to come up with our winners. We're going to announce the winners right now. But before that, my co-host and partner in crime has something that he wants to share with you regarding their solutions. So just to give our judges a minute to put their notes together, I will be handing over to Bule. Round of applause for Bule. He's shy, guys. He's shy.
So it's true. I really am shy. So this is not impromptu, but I'm going to treat it as I was just told 5 minutes ago to make this presentation. So this is just for us to pass time as the judges deliberate. I have been told that I am a good storyteller, so I'm going to try and not keep you awake. This is aimed to put you to sleep, so do not fight the dizziness that's going to come. The objective of this session is to try and get you to sleep. So once upon a time, in a world far, far away, existed a problem. So this problem was a researcher wanted to do PCR, polymerase chain reaction. And this researcher was struggling to get a very important component for PCR, which is primers. And he sat down and he thought, and he thought, and he thought. Are you falling asleep? And he kept on thinking, and he kept on thinking. I've been told that when you use a monotone voice, keep it low, people will fall asleep. So I'm going to try to do that. And he kept monotone. So he thought, what solution can I come up with the problem I have? And he got together with a group of 5 people. 3 of them South African, and 1 was from Switzerland. And the other one was, I have to check that again. But they started now a lab to synthesize primers. And in 2002, they made their first batch of primers, giving a solution to a problem that people had, which was to get primers. And in 2002, 8th of October, the first primers was made, and PCR was then saved. Yippee. And he then thought, what do I call this company? Okay. Oh, yeah. This is exactly what I'm trying to achieve. I have to pour them out of this hole. I have succeeded. Now let's gossip about these judges. Who do you think they're going to pick as a winner? You. Okay, so my story is about a company called Ingaba Biotech. It's a biotech company that now has employed me. I'm telling it like this because Ingaba Biotech was a biotech company that sought to solve a problem. It identified, as Machako has mentioned, a societal problem, researcher problem, and it made a solution to that. And today the company employs, or rather has subsidiaries in East and West Africa, and employs over 150 people. Again, it started as a problem, and the researchers wanted to solve a problem. So to all the work that was presented today, what has definitely been noted is there is a problem that the researchers are trying to solve for. And I hope the story of Ingaba Biotech, it is online. I hope you take that and use it as inspiration for the work that you are doing, because 24 years later now, this company has grown so big to have an annual turnover of over 50 million rands per year. And so I dance for that. But also, to the researchers who are in molecular biology, there was also a big call for funding. We may not have funding in terms of cash, but if you are looking for partnership, again, Ingaba Biotech has been looking and has sent out calls to researchers who are in the same space. Please don't be shy to write to us. I'm not the one who approves, by the way. So if you do approach me to ask or inquire about collaboration, I'm not the one who approves or grants the collaborations. I will connect you to the relevant people. But definitely, this is something that Ingaba Biotech is open to doing, especially when we're having projects or work that seeks to solve these solutions. All the challenges. Yes, we cannot solve solutions.
Thank you so much. Pull a round of applause, guys. Thank you, thank you, thank you. A practical example of solving societal challenges, right? So what we're going to do, we're going to head over to the next item.
The next item, which is was going to be done after the deliberation of the judges, but now I'm going to be calling on stage Prof. Khumotso Simenya, who is the Director for the School of Ecological and Human Sustainability, to come and actually to give thanks, right? He's gonna give thanks. Prof. Simenya, a round of applause.
Thank you, thank you, thank you. Okay, so my job was just to say thank you to the program directors. They say you have done a stunning job, and yeah, it was not easy, but you have made sure that the program goes as organized. We thank you, and I don't know if Baba Law and Dr. Anisha are still here. Santa will take the gift, but I still have you. And where's Pule? Or he's left. This is from to you. It's just a token of appreciation, so that next time you can come running. Okay, thank you. Okay, Pule, I'm waiting for you. He's coming. Okay. Yes, you can dance. This is a token of appreciation from us to you for telling us that boring story. No, thank you, thank you.
Thank you so much, Prof. And I'm wondering, Gugu, I'm wondering if we shouldn't call Prof to come and thank in the absence of our judges. Prof. Libelo. Should we? So what do we do now? Oh, it's restricted. Should we dance? So Usbu is going to be dancing for us. You can play music in the meantime while we wait for our judges. Please don't go. Thank you.
Colleagues, you are asked to dance. Why are you switching off the music? They're asking that you dance. Huh? Okay, they're not dancing. You can switch off the music. Thank you. By the Christmas today, colleagues, when you see me, you know that you're getting some goodies. I have the name of the winners. On position 3. Okay, before you even announce and before I even call the position 3 that I have here, I have also something to say to you. You can just join me, the 3 of you on the stage. I have a token of appreciation. We appreciate the work that you have done. I know it wasn't easy. I think the research that was presented here was good, and it must have been difficult.
It was.
So thank you so much. That is just a token of appreciation from us to you. Thank you. Okay, then I'll give the mic over.
I think as judges, we just wanted to say a few words before the announcement to say that actually congratulations to each and every person that stood up here for their pitch. It was not easy. We know they were nervous, but just to say congratulations, you took a first step into really communicating what your project is about and how you envision this to be taken to a step further to actually do the innovation of your project. So to each and every individual that stood up here, we just want to say congratulations. It does not necessarily mean that your project was just difficult. Like every person's idea and presentation, between the 3 of us, as she was saying that she has bruises because we had to lock heads to say, you know, it was not easy to put it that way. So congratulations to each and every person.
Thank you so much. Okay, colleagues, so we can get to the end of the session. You have heard the judges themselves saying that everyone has done well. So if it was up to me, I would just give everybody the gift. But if you're not getting, please do not be discouraged. It is just unfortunate that we have to have number 1, 2, 3. So now, in our position 3, you know how we do it, the drum roll first. Okay, if I can get here, Marty Oosthuizen. You are welcome. Another round of applause, colleagues. Thank you so, so much. In our second position, drum rolls, we have drum rolls. Refilwe given Kudumela. Thank you, thank you, thank you. Now I'm confused. Pule, you were just doing here, you're not presenting. So I don't know why they wrote here, you here on number 1, and like but it's okay. Maybe they'll come to rectify it. Boo, what's going on? Okay, colleagues, our number 1. They're saying I must mention that you can lift it is sponsored by that is the one that you need to show the colleagues. They're saying it is sponsored by Separations, so we thank them for this gift. Our first position goes to drum drum drum. I'm still confused. What's going on? Do the drum roll again. Maybe let me read this. If you were non to no. He cannot be absent. Why? Why did he? No. Can we have another person? Okay. I said it last time that whoever is not here will give it to this. Okay. There it goes, Colin. Huh? Thank you, colleagues. I'm handing over to you.
Thank you so much, and congratulations to our winners. A round of applause. Yes. And now to the final part of the program. I will be calling on stage Professor Sokholo Lakilibelo, who is the Director for School of Agriculture and Life Sciences, to thank you and do our closing remarks. A round of applause for the professor.
Thank you very much, Program Director. Maybe before I start, a round of applause, please. It's always nice to be the last person to speak because there's no rush. There's no other speaker after me, so I have to take my time. But I understand that it has been a long day. Program Director, I've been tasked with giving the closing remarks and also to do vote of thanks. And before I do vote of thanks, allow me to acknowledge the following. I would like to acknowledge the deanery of the college, Professor Mapoli and Professor Ganta in their absentia. And also I would like to acknowledge the college management committee members who are here. And also I would like to acknowledge the CAES academic community and CAES support staff community. And also allow me to acknowledge the distinguished speakers, the distinguished guests, which were hosted by the College of Agriculture and Environmental Sciences today. And also, I would like to acknowledge all the academics who took their time off to come to this event. Quite interesting that immediately after this meeting, the CODs will be checking on the marking progress. Before I do my closing, my vote of thanks, allow me to underscore and uplift some of the salient matters that were discussed this morning. Prof. Mapoli eloquently welcomed us to this event by sharing with us the progress that has been made by the college in terms of research and innovation. But it was my duty and responsibility to try and find a golden thread which was connecting all the presentations that we had this morning. And Program Director, I think I was quite excellent in determining that. The golden thread in our presentation was around, number one, people-centric research. It was based on innovation. It was based on collaboration. It was based on a translational research. And last but not least, it emphasized on the question of partnership. Dr. Madira, our guest speaker, indicated that based on the two policy frameworks that they do have, they are emphasizing on the partnership with universities. I'm seeing Professor Tulu is struggling to see my page. So to me, that was quite important because it means moving forward, we have to try and to build those partnerships with the DSTR. I nearly wanted to ask us to how often do they visit universities so that we can get that kind of interaction and engagement so that we can be able to say, yes, we can get funding from DSTR. DSTR. Don't panic, please switch it off. Then Dr. Ramalapa from CFR indicated that in a topic on from raw material to the market through enabling clinical and communization, clinical translation and communalization. She said, it is very important that we identify the bioactive compounds that we are working with. And luckily, we do have subgroups and subunits in the college who are working on medicinal plants. Program director, I can indicate to you that I already made an appointment with her. I will be taking my M&D students to her unit so that they can be assisted. I can disclose that so that it doesn't present itself at Matlanga Commission. So those are the key things that I thought were quite exciting to listen to. And especially when Dr. Sia cemented all those presentations by indicating that at Unisa, we do have a unit, DITCC, which deals with that. And you'll agree with me, Dr. Sia, when I say, yours is to try and promote translational research. The days of publishing papers, 20 papers per year are gone. We have to make a point that our research is quite impactful, and it just got a say in terms of improving the livelihoods of our communities/societies. Colleagues, I'm happy that Professor Mavelebele also invited NRF, because we always complain about the funding of our research. And Melissa Govenda and Tate Mazibuko were quite frank with us to indicate that there's a clear distinction between the centers of excellence and the national institutes. So it's up to us. We're even given the scope as to where each and every one of us can fit in those centers of excellence. Colleagues, around the presentation, I'm not going to go deep into the presentations from our researchers, that from Professor Masindi, that from Professor Kulu, that from Professor Ntwasa, and also Professor Jelele. But there is one important aspect that I have to underscore. Professor Kulu, I was happy when you indicated that in actual fact, remote sensing can be linked to physiology and the third. A round of applause for that. He indicated that through that they were able, in KwaZulu-Natal, they were able to trace pregnant women around their response to heat stress. Did I capture it quite correctly? Thank you very much. I always get straight A's during my days. So, Program Director, allow me to thank the following in no order. I'll start by thanking the university management for setting aside this week, starting from the 25th to the 29th of May as a research and innovation week. We truly appreciate the gesture. It's during exams, but they have set this aside. And also I would like to thank the college management for giving us the support and welcoming us to this event, and also blessing this event to encourage us in this engagement. For the external speakers and the internal speakers, I would like to send a word of gratitude to the work that they have done. It's not easy to put together a presentation. It takes time, number one. Number two, when you come in here, you get stressed out. It's not easy coming in here in front of people and talk. And thereafter, you have to be able to answer the questions. And also, I would like to thank the postgraduate students and the researchers who shared with us what they are doing. And I agree with you, Prof, to say it was not easy for you to determine the position 1, 2, and 3. I was not approached to be one of the adjudicators, but when you sat in there, I said it's not going to be easy, given the quality of work that was presented to us. Colleagues, I also want to thank you for attending. You are truly appreciated. You could have attended to other matters, but you chose to be here, to be with us, and to celebrate this R&I Day. Also want to thank our judges, adjudicators, 3 judges. You did an excellent job. Thank you very much. Again, I want to thank our program directors, Sesi Marcel, Awiti Kule, Dr. Radingwana, and Dr. Dean Panther. You are appreciated. I know Professor Semenya thanked you earlier on, but I think I will be failing in executing my duties if I don't thank you. Also, I would like to thank my colleague, Professor Semenya, for presenting all the goodies that were presented to the speakers. You did a great job. And I guess you will be appearing in most of the photos. And that will help you when you do your IPMS. Colleagues, I think I will be failing in executing my duties once again if I don't thank the audiovisual unit. You are truly appreciated. You sat in there doing very well. Some of us, when we look at the pictures that are shown on the screen, we are quite happy and say we never thought we were that handsome. You are truly, truly appreciated. But colleagues, again, let me again thank the organizers of this event. I was given a long list, but colleagues, bear with me. This team was ably led by Professor Mabelebele. We have Professor Mabelebele. We have Me Gugu Masinga. We have Dr. Chabalala. We have Ntate Malindisa, Professor Sebola, Ms. Gugu Ngobo, Sesi Kate Mafate, Cecil Rato Makole, Ntate Manyatse, Rufio Manyatse, Ntate Godfrey Munyai, and last but not least, Ms. Emelda Pimentel. A round of applause, please. When I checked on the ratio on this, it's 8:3, which sounds like a baseball score, but I understand where we are coming from. We have got 8 females in this team. We have got 3 males. At least the male species is still there, did not face any extinction. Colleagues, in the event that I inadvertently missed one of you, that was not my mistake. That was not intentional, and I wish you all of the best. Thank you very much. A round of applause, please.
Thank you so much, Professor. And we've reached